Good evening, everyone. Yes. Thank you. Thank you. Good evening, everyone. Right. Now let us continue the topic. What is that? AC bridges. We need to start. But before going to take that, simple revision I'm giving now. Here, medium resistance measurement. Medium resistance measurement. What are the methods we have seen in yesterday's class? VA, AV we have seen day before yesterday. And yesterday we have seen substitution, Wheatstone bridge, and ohm meter. Okay, and high resistance measurement. What is that? Direct deflection method, Lassa charge method, and Meg ohm bridge method. And finally, Megger we have seen. Clear? Right. Concentrate here. In this entire thing, you have seen each and every discussion clearly, and I told you here correspondingly objective way of preparation I gave you, but in the conventional point of view for ESC people, when I take the mains, Megger construction, I will explain, already told you. Okay. Now, after so many questions also we have seen, but be clear, in the bridges, because of lack of network theory practice or network theory might have not done in the AS Academy so far. So therefore, concentrate. I'm giving one more point, one more time, because yesterday also many people asked the same thing. So numericals are very simple while you're explaining, but how to get the idea? Very simple, yeah. Whether it is balanced or unbalanced. Suppose simple logic here. 5 4 is 20, 10 2 is 20. Okay, what we can write now? This is C and this is D. So therefore, VC is equal to VD when the bridge is balanced. So what is VC? Either V across 10. If you are taking V across 10, you should take V across 4 because C to this potential, which one? B. D to also B only way to take. Otherwise, second way of explanation also I gave you. VC, sir, I'm taking from this terminal, no problem. V5 is equal to V2. Okay, what I told you here simply, sir, voltage division law. Sir, these two are perfectly in series. Yes, we can apply voltage division. Here also voltage division. But main problem coming here is, sir, if this resistance is 6, for example, 5 6 is 30, 10 2 is 20. Yes, there is no zero current. I mean, there is a current through the corresponding galvanometer. Here also people are getting confused. So how do you apply the voltage division law? You are missing something. So voltage across this V0 is equal to VC difference of VD, VC minus VD or VD minus VC. Okay, my question here is VC minus VD means C to D current is flowing. VD minus VC, D to C current is flowing. That's not the point. But under this condition also, how to get voltage across C means I'm taking this one. Sir, you treat these two are in series, but everyone is having the doubt genuine. But sir, here it is path provided. Now, how to write means already told you. You assume this as open, but immediately, sir, not equal to 0. What does it mean? Automatically we are not opening, we are showing the difference. VC and VD difference is not showing, not 0 means automatically we are showing the difference, so no need to worry. So that's why anything is given, you take it. Otherwise, if this resistance is given, etc., then you can go for what is it here, other KCL KVL notation. But in this case, galvanometer is not given, no problem. So directly you can apply the voltage division law without any second thought. Right. We are having many things to learn today. Very good, very good. Right. Now, I'm taking the yesterday's homework question. Right. First of all, before answering, now let me know what is the answer. I told you 100 is wrong. What is the answer? Very nice. Yes, very good, very good. Tony, Jitendra, Ayush. Satish, wrong. Cartoon Kids, wrong. Right. Other people are correct. Yes, yes, yes. Very nice, very nice. Sandeep Venkat, kindly check it. Ramachandra Kashyap, check it. Manish, Vikas, Veerababu, kindly check it. Vinita, check it. Pranavi, check. Other people give the correct only. And Akash and Pallavi, kindly check this. Right. Don't worry. Whatever the names I have taken, those are wrong answers. No need to worry. Yes, let me take now. Very small confusion here. If you overcome that, the thing will be done. Because Wagner, 200 is wrong answer. Right, concentrate here. For idea purpose, I am drawing this diagram like this. Just I am modifying this. What is that? Under balancing condition only. Generally, here the circuit galvanometer shows 0 means balancing condition only. So I'm writing that. I'm taking that point. Concentrate here. This is 100. This is 200. 100. 100. Okay. After that, sir, it is open, sir, because current is 0. He only has given this. This is 100 and Rex supply. What is it? 2 volts. Okay, right. The first mistake many people did in the yesterday's class only. Many people give that 100. Many people give that 100. Right? What is it? Aishwarya, not 50 here, not 50. I'll tell you. I'm saying now here. Sir, what is it? Here, these two are in series. Yes, 100 plus 100, 200. I'm drawing the diagram again. This is 100, 200, and here to here, one resistance 200. Here, just idea purpose, I'm drawing many diagrams. Otherwise, not required actually. Rex 100. Okay, right. This is 2 volt. Finally, what people are writing, like this, directly writing, sir, 100, 200, 200, 100, 100, Rex, and like this. Simply by treating like, sir, okay, Rex into 100 equal to 100 into 100. So therefore, Rx equal to 100. Many people in the yesterday's class gave. So that's why I gave you 100 is the wrong answer. I gave you. Hema, kindly check it. 100 is the wrong answer because concentrate. Here, go back. Sir, this is the C potential. This is the D potential. If the galvanometer is showing 0 means this VC and this VD should be equal. This is A, this is B. I'm taking this as some E terminal. Okay, right. Sir, if you are making these two are in series, 100 plus 100, 200 means automatically C node is vanished. C node is vanished. What is this? This is A, this is B, this is D, this is E, not C. Where is C? Here is the C. But as these two are taken in series, 100 plus 100, 200. So therefore, C node is vanished. Okay. So therefore, this is A, this is B, this is D, this is E. Suppose if you say 100 into Rx equal to 100 into 100 means, what is the logic here? Sir, VE is equal to VD, but is it? No, VE is not equal to VD. VC is equal to VD. That's why terminology point of view, very, very important. VC equal to VD. But in this, what you're doing here, if you're making these two are equal means, it implies galvanometer is connected here. Are you connecting the galvanometer between D and E? No. That's the first point. I told you this only wrong in the yesterday's class. Okay. Now, we need to go in the reverse way. Sir, this is 2 volt. So therefore, across this 1 volt, across this also 1 volt. Clear? Because 1 plus 1, 2 here also, but not required. Leave it. Right? Okay, otherwise write it across this one like this. In this circuit. But concentrate here. I'm taking these two. We people are writing, sir, 1 volt and 1 volt people are writing. Is it correct or wrong? This is 1 volt and 1 volt. Correct or wrong? Come on. It is wrong because, sir, if these two resistors are equal, then we can say 2 is divided to 1 and 1, but we don't know Rx value. And we know that, yes, Rx is not 100 also, we know, because this and this we cannot take because that is simply wrong procedure. So therefore, only here we can say 100 and 100 is there, 1 volt and 1 volt is there. Okay, yes, simply 1 volt and 1 volt. After that, sir, across A and E, 1 volt is there. Across E and B also 1 volt is there. Sir, these two are in parallel. Concentrate. These two are in parallel means across this also 1 volt is the parallel. 1 volt, 1 volt. Parallel is same voltage only. Now we need to go back again. Sir, across this 1 volt. Sir, across this 1 volt means across this 0.5 volt, across this 0.5. Check it. 0.5, 0.5, 1. Is that no? 1 and 1 parallel, 1 volt only. Yes, 1 volt only, 1 volt only came into picture. Now observe it, sir. At this node, which voltage is there? At this node, which voltage is there here? This is 0.5, this is 0.5 means at this node, either with this node, what we can say? 0.5. So therefore, VC is equal to how much value? 0.5, not the 1 volt. VC is equal to 0.5. Clear, guys? So therefore, 0.5 plus 0.51. So therefore, VC is equal to 0.5. So therefore, finally, what we can write now? Therefore, VC is equal to 0.5 and VC is equal to VD is equal to 0.5. Okay, now, sir, what about this one? It is a series circuit. What is the total voltage? 2. What is the voltage across Rx? VD. What is VD already? They are 0.5. So therefore, simply VD is equal to 2 volts into Rex by Rex plus 100. Simple voltage division law. That's why in this purely circuit basic approach is there. Nothing more than that. Circuit basic approach is there. Right? Yes. It's 2 volt. Okay. Clear, guys? Right? Now, here. Now, what is the VD? 0.5 is equal to 2 into Rex by Rex plus 100. What is this? If you are taking the cross multiplication, what will be there here? This is 10, 4. So therefore, simply Rex plus 100 is equal to 4 Rex. 3 Rex is equal to 100. Rex is equal to 33.33 ohms. This is what the complete procedure. So that's why in this nothing to do. Simply where we have connected the galvanometer resistance is 50. Right? Anyway, it is showing 0 means the current flowing to the thing is 0. Automatically, it will be open circuited. If it is open circuited, yes, this potential is equal to this potential. So automatically VC equal to VD means yes. Here, what is that? These two become series 100, 100, 200, parallel 100. From this again, we need to go back. That's what the procedure. So 2 volts divided into 1 and 1. This one across EB, 1 and 1 parallel, no, 1, 1 only. Again, sir, across 1 1 means 0.5, 0.5 because equal resistance. This potential is 0.5. If this is 0.5, it is also 0.5. Automatically 33. Right, right, sir. People are asking that, sir, converting star into delta, delta into star. First of all, where is the delta in the figure? Where is the delta? Our circuit is, what is it here? You're missing small thing here. Don't think it is delta. So kindly see, sir, yes, it is in delta. People are thinking that, sir, this is in delta. That is not in delta. See, triangle shape is the delta. No, yeah, delta is when three terminals are separately taken. But in this, once it is open circuited, this branch and this branch coming in series only. Where is a delta existence here? There is no delta existence at all. So that's why don't go by delta to star, star to delta process. People are saying that, sir, I'm converting this into star connection like this. First of all, it is not delta. It is not delta. When you can say delta, if connection is there, then you can say delta. But delta connection itself is not there. That's why it is simply series parallel circuit only. Clear? Right. I solved by delta. Which delta you have taken? Answer may be sometimes wrong. Even though we are doing small mistake, final answer may be correct. Final answer may be correct, but don't say that is correct procedure. I'm asking, where did you take delta? Where you take delta? Those who told that answer I solved with delta. Answer comes by converting delta to, so first of all, delta itself is not there. 100, 100, 200 means before opening or after opening, before balancing or after balancing. Come on, before or after balancing. Suppose if you want to open, if you want to convert delta to star, this diagram as it is, you need to include the 50 also, then you need to proceed. But normally we cannot. That is the reason why the best method, actual bridge balancing technique is this only. Kindly concentrate. Before opening, that is okay. But our topic is galvanometer is showing 0 means we need to follow which one here? Balancing technique only. That too. If this is the same model, question is given in the ESC conventional 3 marks or 4 marks, etc. This only the procedure you have to do. Don't do star to delta, delta to star. No. What is it? He mentioned clearly. Already galvanometer shows 0 means balancing condition. From the balancing condition only we have to follow. In the objective, even if you take some other procedure, you may be getting the correct answer, but this is the actual procedure. Clear? So this is the total discussion regarding resistance measurement. Completely resistance measurement you have taken. Right now, I'm starting AC bridges. I'm starting AC bridges now. Sir, what is AC bridge? I told you the AC bridge means, what is that here? AC supply, otherwise oscillator and detector, different types of galvanometers, etc. Introduction we are taking, no, same thing, but concentrate. Sir, 4 branches I'm taking, but which branches we don't know. In the introduction topic also I have taken only boxes like this, because in this box R may be there, or RL may be there, or RC may be there, RL series may be there, RC series or RC parallel, anything may be there. That depends on the different types of bridges. Okay, simply I'm taking like this AC supply V, F. V, F. So therefore, this one I'm taking as Z1 at an angle plus or minus theta 1 means it may be R plus JXL or it may be R minus JXC. Anything is possible. Z2 magnitude. I'm taking this as Z3 magnitude at an angle plus or minus theta 3. Here Z2 magnitude will be there as well as corresponding angle also will be there. It may be anything, right? Plus is there means L combination, minus is there means C combination. Sir, Z4 magnitude at an angle plus or minus theta 4. And sir, what is the balancing condition? What is the balancing condition? What is the balancing condition? I told you opposite branches. So therefore, what is it here? Z1, Z4 equal to Z2, Z3. Z1, Z4 equal to Z2, Z3. But here, so far we have concentrated only on magnitude because that was a DC. Now onwards, we have to concentrate on DC as well as AC, both. Sorry, magnitude as well as angle, both, because it is AC. Earlier DC only magnitude, but here AC magnitude as well as correspondingly angle also. That's why concentrate here. What is that? I'm separating the magnitudes and angles, but before that, Z1 magnitude plus or minus this, Z4 magnitude plus or minus this is equal to Z2 magnitude plus or minus theta 2, Z3 magnitude plus or minus theta 3. It's not actually equation. But while you're simplifying, we need to separate real and imaginary terms to get the equation. So therefore, magnitude Z1, magnitude Z4 should be equal to magnitude Z2, magnitude Z3. And angles anyway added plus or minus theta 1 plus or minus theta 4 is equal to plus or minus theta 2 plus or minus theta 3. These two must be satisfied. Then we can say the given bridge is balanced. Suppose, sir, this is satisfied. If this is failed, bridge is not balanced. That's why be clear. Both magnitude and what is it? Angle equations must be satisfied. Both magnitude and angle equations must be satisfied. Then only we can say the bridge is balanced. This is a simple introduction regarding the AC bridges. This simple introduction regarding AC bridges. Clear? Now, I'm taking first topic in this. Full of mathematics will be there. Sir, measurement of inductance. Measurement of self-inductance. Right. So what is this measurement of self-inductance? There are 5 methods available. There are 5 methods. Measurement of self-inductance is by 5 methods. What is that? First of all, first one, Maxwell's inductance bridge. Maxwell's inductance bridge. This is Maxwell's bridge, not your bridge, not my bridge. So therefore, we need to follow his bridge as it is. Structure, but concept I'll give you completely. And he only, Maxwell's only, right? After identifying this one, some drawback is there, etc. He has proposed other bridge, Maxwell's inductance capacitance bridge, right? Third one, Hayes bridge, right? Fourth one, Owens bridge, and fifth one, Anderson's bridge. These are the 5 bridges available. In each and every bridge, which value can be measured, experimentally proved, few things are there, and corresponding explanations, everything will be given. But very important task here is, if I say Maxwell's inductance bridge, automatically the moment I say the name, you should be able to recollect the diagram, recollect the corresponding bridge circuit. That is what the biggest task. But how to prepare, how to get it, I'll tell you later. How to get it in the shortcut way, I'll give simple procedure is there, you can get it. The first one, I'm taking Maxwell's inductance bridge. Maxwell's inductance bridge. Right. Complete mathematical approach only. The concept is similar. What is that? Variable element must be varied until the galvanometer shows 0 over. After the showing 0, automatically what we can say? Yes, correspondingly, we can get the unknown values. Okay, right. Concentrate here. What is Maxwell's inductance bridge? What he proposed? Here is, this is the bridge proposed by him. This is the bridge proposed by him. Here, R and L. I'm taking this as R1, L1. This is unknown branch, nothing but unknown coil must be placed between these two. Okay, after that, this is his bridge. He proposed this as R3, this as R2, L2, this as R4. Okay, and here he proposed galvanometer or detector. I told you already, vibration, galvanometer, etc., etc. And supply. At any cost, you must be able to recollect this bridge. When the name is given, Maxwell's inductor, it means that you must be able to draw. In that way, you need to practice. Okay, very simple. Sir, what is the balancing condition? Our topic is always from the balancing condition only. So therefore, yes, sir, balancing condition. Right. Sir, what is balancing condition? Concentrate here, sir. Z1, Z4 is equal to Z2, Z3. Z1, Z4 equal to Z2, Z3. Sir, what is Z1? R1 plus J omega L1. Sir, Z4, single R4. Right? Z2, R2, L2 series. R2 plus J omega L2. Z3, R3. Okay, simply multiply. What will be there? R1, R4 plus J omega L1, R4. R2, R3 plus J omega L2, R3. Clear? After that, separate the real and imaginary terms to separate the values. Simply R1, R4 is equal to R2, R3. J omega L1, R4 equal to J omega L2, R3. After that, sir, J omega cancel. So what is the answer now finally? R1 is equal to R2, R3 by R4. Actually, our topic is self-inductance only, but with this procedure, not only inductance of the coil, but also resistance of the coil is being determined. That is added advantage. Happy. And from this, L1 is equal to L2 R3 by R4. L2 R3 by R4. This is what the complete discussion regarding which one here? R1, L1, but unknown coil measurement. Unknown coil, self-inductance and its own resistive drop measurement. Simple logic. If you understand the bridge within 1 minute, you can have this answer with it. But my question is, sir, very important. This is the question in the ESC objective paper as well as state level examination also. This question will be there. Sir, in order to get this result, right, bridge must be balanced. In order to balance the bridge, out of this is anyway unknown. Out of these three branches, one branch must be variable definitely. Without varying this, do you get galvanometer current directly zero every time? No. So that is the reason why we need to make galvanometer value as zero. We need to make galvanometer value as zero. So therefore, what do you have to say? Out of these three, which is the variable parameter? Considered, he has proposed. Right? He has proposed directly, but I'm not giving the blind one. Simple shortcut I'm giving to remember. Actually, he has proposed. These two are variable. Who has proposed? Maxwell's has proposed. But how to remember this? How to remember? Kindly concentrate. Sir, why are you taking this? I have not taken. I am not taking. I have not taken this. He has taken already. That's why I told you. This is his bridge. His rules must be followed. After this, in order to explain, in order to understand, yes, I'm taking this complete mathematics. Okay, sir, how to get this one? Simple logic. Other than this, three branches, one branch will be variable. But which is the variable? Check it here. R2, L2 are the variable given by Maxwell. But how to remember that? How to identify means simple. Sir, R4, R4. In both the results, R4, R4, same element is there. R3, R3, same element is there. So automatically we can frame one shortcut like, okay, in the result of R1 and L1, uncommon different elements must be taken as the variable. But kindly don't get question like, sir, why different elements are being taken? No, not that actually. He has taken already. But how to remember that? I'm giving a simple shortcut because remembering the diagram, remembering all the very difficult. That's why simply if you remember the diagram enough from the result only, what he proposed as the variables, we can answer. That's why simply how to remember the shortcut? Uncommon elements are as variable elements. Uncommon elements are as variable elements. This is the complete discussion regarding what is a Maxwell's inductance bridge figure as well as corresponding mathematics. Okay, sir. If coil is there, this is the unknown coil, this is the unknown coil, and we determine the corresponding self-inductance of the coil and resistance of the coil also. Okay, okay. But my point here is, sir, coil is there, automatically we measure coil is there. We measure which one here? If coil is there, we measure quality factor. We measure quality factor. So what is the quality factor formula? So generally, concentrate those who are not done with the corresponding, those who are not done with the corresponding network theory, no need to worry. I'm giving the formula. Quality factor Q formula is omega L1 by R1. Sir, how? You'll be having the derivation in the network theory, no need to worry. No need to worry. Sir, this is there in the network theory. You have taken this and you solve so many questions and everything. But my point is, sir, this is not valid. See, formula is not wrong, but this quality factor omega L1 by R1 concept itself is, what is that? Formula itself is not valid in this bridge. Means some problem is there in this bridge. What is that problem? That's what I'm writing here. Q equal to omega L1 by R1 is not valid in this bridge. Is not valid in this bridge. Why? Means my question is not valid in this bridge. That is right. Quality factor cannot be determined. Quality factor cannot be determined with this bridge. With this bridge. Only with this bridge we can determine resistance of the coil, inductance of the coil only, but not the quality factor. Why? Kindly, those who have completed network theory, they can answer. Other people, I will give you, no need to worry. Can you respond those who completed the network theory in the AS Academy? Sorry. Cannot be. Okay. Yeah, cannot be only. Why? Cannot be. Yes, cannot be only. Yes. Okay. That is okay. Cannot be. I told you, but I have written that cannot be determined with this bridge. Why? Those who come to network theory, kindly answer. Right. Those who completed network theory, I'm asking them only. Other people don't try to give the answer. Don't. I'll give you. Very nice. The quality factor is defined at resonance condition. Quality factor will be defined under resonance condition. In order to get the resonance condition, what is it here? XL must be equal to XC. L and C both must be required. But in this, capacitor itself is not there. In this, capacitor itself is not there. That's why what we can write here. But kindly don't ask the question like, sir, why the resonance condition only? Why the capacitor required? That you study in the network theory. That's why from that basic, I'm extending my theory. That's why be clear here. The quality factor is determined, defined only at resonance condition. But in this, there is no capacitance in the circuit. Therefore, without the capacitance, we don't have any capacitance at all. Is that no? That is the reason why. Be clear, be clear. Therefore, what is that? Bridge, because those who are not done with the network theory, don't worry, take this point for guaranteed. What is it? Resonance quality factor is defined at resonance condition. Resonance condition means L and C both must be there. In the C is not there, therefore we cannot determine. That's why problem is not with the formula, problem is with the bridge, because the resonance condition, because the resonance condition cannot be obtained. Resonance condition cannot be obtained. This is what the very, very important. That's why Maxwell only observed that, okay, sir, resonance condition is not possible. Means, okay, inductance is determined, but something is missing. Resonance condition is missing. So therefore, he only proposed that correspondingly resonance condition related bridge, that is, first bridge is not completed, only circuit diagram, bridge circuit, mathematics, and corresponding quality factor possible or not means not possible. We have taken this. Okay, then the point here is concentrate. I'll be coming back to this later after this. Now, he only proposed second bridge. Which bridge? Maxwell's inductance capacitance bridge. So simply, sir, capacitance was not there. Simply, he has kept the capacitance in the circuit. That's it. Right. We can add the capacitor. Kindly concentrate. People are asking, who is this? Because. So we can add the capacitor. All I told you, this is not Vikas bridge. This is not Ramesh bridge. This is Maxwell's bridge. Are you getting my point or not? This is not our bridge here. We cannot add according to our requirement. Suppose if you're adding somewhere, etc., we need to give our name. That is not Maxwell's bridge. Take it for granted. That's why we can add the capacitor. No, we cannot say that. We cannot say that. Here, this is the bridge. Suppose if we want to add, why do you take his name? Simply measurement of inductance, some X bridge or my name bridge or your name bridge. That's why I told you before starting only. I know these type of answers will be able to pick. That's why I know whatever he has given, that only to be taken. Otherwise, that bridge becomes our bridge. That bridge becomes our bridge. Yes. So that is the reason why. Be clear. Be clear. He only proposed means their capacitance is missing. He is connecting, not we, not I am connecting, not you. You are connecting. Simply. What is it? Maxwell's inductance capacitance means he only proposed. Sir, how? Concentrate. This is the bridge, right? Here again, sir, R and L, R1, L1, same unknown branch we are connecting here, and here, R3. Here he proposed R2. He proposed RC parallel like this. This is R4. This is C4. Anyway, supply is given here, V, F. Here, as usual, detector or galvanometer, no problem. Clear? Right, sir. In this, based on the concept, he has taken as a variable. I give simple shortcut. No, from this entire shortcut, we need to give the answer which are variable in the second model. Right? Now, the point here is, sir, same logic again. Sir, Z1, Z4 is equal to Z2, Z3. What is Z1? R1 plus J omega L1. Z4, R and C parallel. So therefore, R4 by 1 plus J omega R4 C4 into Z2 singular, Z3 singular, R2 into R3. Oh, very simple. Sir, the denominator, bring other side. R1, R4, I'm multiplying, plus J omega L1, R4 is equal to, multiply, R2, R3 into 1, so R2, R3 plus this entire thing, J omega R2, R3, R4, C4. Simple two-step answer. Now again, separate it. Separate the terms. What is that? R1, R4 is equal to R2, R3. J omega L1 R4 equal to J omega R2, R3, R4, C4. Okay, right, sir. J omega, R4, R4 over. So finally, sir, R1 is equal to R2, R3 by R4. L1 is equal to R2, R3, C4. I gave you one shortcut. Now tell me, with this result, which is the variable branch? By using the shortcut, what I told you. Actually, he has taken variable branch, but to understand that, I gave one simple shortcut. Now tell me. Come on. Very good. Few people. Kindly listen the class carefully. If you have listened the earlier topic, you don't give the wrong answer. Yes. Of course, almost only two people have given the wrong answer. It seems. See what I told you here. Actually, come on here. Actually, he has taken something as a variable. But how to remember? I told you, sir. R2, R2, same. R3, R3, same. So therefore, what you to do here? R4, C4, uncommon, uncommon. Therefore, variable. And that too, this shortcut is not valid everywhere. Wherever it is valid, use this. Otherwise, you need to remember the bridge as it is. You need to remember the bridge as it is. Yeah, many people give the correct answer. Correct. Clear, guys? So therefore, he proposed, but how to remember? Shortcut I gave you, but shortcut is not valid for every bridge. That's why we need to follow the bridge given as it is. Okay, sir. R1 is there, L1 is there. Okay, sir. What is the quality factor of this? Yes, we can find out here. What is that? Quality factor. Q is equal to omega L1 by R1. Obviously. Sir, omega. What is L1? R2, R3, C4. R2, R3, C4 by R1, R2, R3 by R4, R2, R3 by R4. Simply R2, R3 cancel. Therefore, quality factor Q is equal to omega R4, C4. Quality factor Q is equal to omega R4, C4. Therefore, yes, we can determine the quality factor, but concentrate here. Sir, people are getting confused. So it is a quality factor of R4, C4 branch. No, no. Quality factor of unknown branch in terms of the known branch in the circuit. But kindly don't say quality factor of fourth branch. No, yeah. Quality factor of first branch, which is unknown only. But the bridge itself is unknown value in terms of known value. Why? R is equal to P by Q into S normally. Therefore, unknown value is in terms of known values. Unknown value is in terms of known. Here also same thing. Unknown element quality factor is in terms of known quality factor, known values. Clear? Right. I'll give you what is that value, everything I'll give you. Okay, quality factor is positive, means Maxwell's inductance and Maxwell's inductance capacitance. First one, quality factor is not possible. Here, quality factor is possible. Okay, some other mathematics I'll give you. Next, third one. What is that? Hayes bridge. First, I'm taking all the bridges concept. After that, other topic continuation I'll take. Hayes bridge. What is Hayes bridge? Here, same thing, R and L, R1, L1. This is anyway unknown, and this is R3. This is R2. He has proposed RC series. He proposed RC parallel, but he has proposed RC series. Okay, this is R4, C4. Very simple. Now, concentrate, guys. Concentrate. Here, this is the galvanometer. The simple one. He proposed this as the variable. Who proposed? Who proposed here? What is it? He has proposed that as the fourth branch as the variable branch. He proposed. That's why I told you shortcut is possible. With this result, I'll give you. If shortcut is not possible, I will give you directly. You need to follow that as it is. After that, very important concept. Z1, Z4 is equal to Z2, Z3. Z1, Z4 is equal to Z2, Z3. Okay. What is Z1? R1 plus J omega L1. Z4, R4 minus JXC4 equal to Z2, Z3, R2, R3. Everyone concentrate. This is, I'm not saying that leave it, I'm saying that homework. You need to multiply, you need to simplify. So R minus Jx is there, minus J is going downside, plus J, like that. Simplify this, and not now, take it as a homework, but I'll give the answer. This purely mathematics. Okay, R1 is equal to, and L1 is equal to, you will get the something. That's why I told you concept is very small. What is that? Variable element must be varied until the galvanometer shows 0 over. After that, simple mathematics only. But this mathematics plays major role in the corresponding term. That's why I'm giving the homework only for not topic wise, mathematics wise. You can have good practice. But I'm giving the hint. If you're simplifying this, you'll be getting R1 equal to L1 something. L1 equal to R1 something. Is it completed equation? Is it the completed equation here? No, it is not the completed equation. Why? R1 is unknown, L1 is unknown, unknown in terms of some other unknown, unknown in terms of some other, not complete. That's why you substitute L1 value here, R1 value here, and again you need to proceed. Then you will get the answer. This is almost 10 to 12 subject mathematics, 10 to 12 steps mathematics is there. So kindly concentrate more. Clear? Right? Now, I'm giving the answer. Don't worry. I'll give the answer. Answer here is 1 plus omega square R4 square C4 square R2 R3 C4. 1 plus omega square R4 square C4 square omega square C4 square R2 R3 R4. This is what the answer. It is somewhat lengthy mathematics. That's why I'm giving the answer directly. Right. Why didn't we check the phase conditions? Vishnu, very good question. Here, magnitude and angle. Are we checking both conditions or not? Sir, magnitude and imaginary. If you are taking both means, we are taking in the rectangular form, in the numerical question, in the what is the polar form? It means we are checking both conditions only. Vishnu, concentrate. We are taking both the things, real and imaginary. Yes, we are taking both means we are checking both the conditions, not only one. Suppose if I take only R1, only R, only R, then that is called as, yes, what about the angle, etc. If I take the imaginary element, so automatically angle is there. Angle is there. Clear? Right? Okay. Right now, sir, after this, at any cost, you need to follow all these formulae. That's what I told you in these bridges, that especially in the AC bridges, concept is less, mathematics is very lengthy mathematics. That's why be clear with the terminology. Okay, after that. Right. See, did I say that MI bridge is over or Maxwell's is over, Maxwell inductance bridge is over? No, yeah, no. I told you I am giving bridge circuit and quality factor. First, I will come back. Already told you I will come back. I think you might have slept, Rohit. I think you were sleeping at that time, it seems. So kindly concentrate. I told you I will come back. I will come back. No need to worry. Clear? Right? Okay. Now, clear, guys? Right. Now, sir, after that, quality factor. Quality factor Q is equal to omega L1 by R1. What is omega? So as it is omega. So what is L1? This entire thing. Let me write the entire thing. R2, R3, C4. Okay, R2, R3, C4 by 1 plus omega square R4 square C4 square. Okay, then so this entire thing omega square C4 square R2, R3, R4 by 1 plus omega square R4 square C4 square. Nothing but I substituted these two values. That's it. Nothing more than that. I have substituted these two. Right? Now, concentrate here. Sir, cancel. R2, R2, R3, R3, 1 C4, cancel. 1 omega, cancel. So therefore, Q is equal to 1 by omega R4 C4. Check it, 1 by omega R4 C4. So quality factor is possible. Why? Capacitance is there. Automatically, what is that? The corresponding quality factor measurement QF means quality factor measurement is possible. Clear? So this is the three bridges structure. What is Maxwell's inductance MI bridge, Maxwell's inductance capacitance MICB, and Hayes bridge. Right? Okay. Now, next one. I'm taking fourth bridge. I'm repeatedly saying I'm taking only bridge structure, R1, L1 determination, quality factor only. After that, I'll go back again. I'll be taking some other concept and all. No need to worry. Owens bridge. Owens bridge. So what he proposed, in this Owens bridge, like this, sir, R, L, R. Here he proposed RC series and he proposed C here. This is R1, L1. This is R3, R2, C2, C4. This is the galvanometer. This is the galvanometer. Clear? Now, very, very simple. Sir, again, same mathematics here. Only the headache here is recollecting the bridge. But how to remember all these bridges? I'll give you the simple shortcut process. This is anyway unknown. That's why I told you. I told you already. I'm repeating this. Today's class, once you see my, what is that? Steps, each and every, it will be clear. Yes, okay. But once I give Owens bridge radar diagram, means you should be able to draw. Means you need to practice more and more and more, especially in the today's class. So far, at least concept I told you. But here, concept is very simple. What is it? Take the bridge, balancing condition, find out the math. Everything is mathematical based on. That's why you need to practice more and more to recollect the bridges. That's not the point. Okay. Now again, Z1, Z4 is equal to Z2, Z3. What is Z1? R1 plus J omega L1. Z4, 1 by J omega C4 minus JXC4. No, equal to, what is it? Z2? R2 minus JX2 or R2 plus 1 by J omega C2, right? Into R3. Into R3. Clear? Right? Now, here, what is that? R1 by J omega C4 plus, here, J omega cancel, L1 by C4. Clear? Equal to R2, R3. R2, R3. plus R3 by J omega C2. Simple step, only one step. Okay, now, sir, real parts, no imaginary, no imaginary. So therefore, what is that? If I equating these two, what you're getting here, L1 by C4 is equal to R2 R3. L1 is equal to R2 R3 C4. Okay, now, sir, R1 by J omega C4 equal to R3 by J omega C2. J omega cancel. Okay, now what is unknown? R1 is unknown. R1 is equal to C4 by C2. C4 by C2 into R3. This is what the corresponding R1. Now with the earlier shortcut, which is the variable element. With the earlier shortcut, which is the variable element. Correct. Very nice. What is it? Uncommon branch, sir. C2, R2 uncommon because C4, R3, R3. So automatically, what is it here? This is uncommon. Nothing but variable, right? Clear, guys? So this is the point. Now, again, same procedure. What is that? Quality factor. Sir, Q is equal to omega L1 by R1. Omega. What is L1? The L1 is R2, R3, C4. L1 is R2, R3, C4 by C4 by C2, R3. C4, R3 by C2. So automatically what will be there here? C4, C4, R3, R3 cancel. Quality factor is equal to omega R2 C2 over. Quality factor can be determined. Clear, guys? So these are the four bridges, one by one. Construction correspondingly, mathematical analysis, everything we have taken. Anderson's bridge I will take later. After this completion of all these four topics, we'll be going to Anderson bridge separately. Right now, I'm going back, sir. This is Maxwell's inductance bridge. Maxwell's inductance bridge. Concept point of view, everything is done mathematically, but that may not be there in the gate paper directly, but conceptual questions may be there. So that's why I'm going to draw the phasor diagram now. What do you mean by phasor diagram? Kindly concentrate here. Kindly concentrate how to draw the phasor diagram. Everything is important here. If you understand this entire phasor diagram, you can draw any circuit phasor diagram without any confusion, because in this resistive, that is in phase, lagging, leading, combination, current addition, voltage, and different combination we are going to take. So that's why until I complete this, keenly observe this, how to draw this entire. If you understand one phasor diagram, other things will be very simple. But concentrate here. Sir, here, first branch now I'm taking as E1. So terminology point of view. I1, E3, I3. Means number, same number I'm following. Here, I2, E2. Here, E4, I4. First point. So under balancing condition, it shows 0. If it shows 0, I1 equal to I3. Nothing but C is equal to D common. This is A, this is B. Okay, first let us write. Under balancing condition, what is that? First one, Ig is equal to 0. Ig is equal to 0. It implies Vc is equal to Vd, balancing condition. Sir, what is Vc? E3. What is Vd? E4. So automatically E3 is equal to E4. All I told you in yesterday's class, sir, if these two voltages are equal, obviously these two should be equal, definitely. Then only, yes, sum of those two should be equal to this. So therefore, what is it now? E1 is equal to E2. This is nothing new. Yesterday's topic only. Yesterday's topic only. After that, sir, I1 is equal to I3. I2 is equal to I4. Sir, why? Check it. Sir, I1, same current. I2, same current. So therefore, I1 equal to I3, I2 equal to I4. Okay, after that, sir, what is the supply voltage? What is the supply voltage? Check it. Sir, supply voltage E, we are anything you take. Supply voltage E. E is equal to, sir, sum of these two. Otherwise, sum of these two. Both will be same only because simple voltage constant. Clear? So therefore, the point here is, what is it here? E1 plus E3 are nothing but E2 plus E4. I'm going back again. Check it. E1, E3 added to get E. Otherwise, E4, E2 added to get the value of E. Am I clear? Right. People are asking, sir, I4 direction is reversed. Why here? Supply is coming here. At this point, divided. This current is coming here. This current is coming here. Both are added here, same direction. Vaishnavi, check it, check it. Current direction is correct only. I2 coming here, I4 going like this. Here to here, current is flowing. Everyone, kindly concentrate. These are called as balancing condition. These are called as balancing condition. Concentrate here. These are called as balancing conditions. Clear? Okay, sir. These are balancing conditions. Okay. Now the question here is, from the circuit, what is E1 formula, E3 formula, E2 formula, E4 formula? Sir, what is E1? I1 into R1 plus J omega L1. Even magnitude is this magnitude. So therefore, I1 into R1 plus J omega L1. Next. Sir, E3. Come on, guys. E3. I3 into R3. I3 into R3. Sir, E2. E2 is I2 into R2 plus J omega L2. So therefore, I2 into R2 plus J omega L2. E4. Sir, what is E4? E4 is only single element R4. So therefore, I4 into R4. I4 into R4. Clear? Right. Everyone kindly concentrate. Step by step, I'm going to explain phasor diagram of all the 4 bridges. I'm going to explain. No need to worry. Kindly, after the class, if any doubt is there in the phasor diagram, kindly go through the recorded videos only. Kindly concentrate. No one should get deviated. It is very simple, but no one should get deviated. First, how to draw the phasor diagram here is, first I'm taking I1 as a reference. Sir, why only I1? We don't know. Something as a reference. Reference vector only for explanation purpose. Sir, this is I1. Everyone, every step by step you have to concentrate. If any small confusion is there, we'll be clear in second bridge, third bridge, 4 bridges I'm going to take. So be clear with the terminology. Okay, concentrate here. I1. Sir, where will be I1 R1? I1 is here we have taken. Where will be I1 R1? I1 R, no, don't answer, kindly concentrate. I1 R1 will be in phase. Wherever you want, you can take it. Magnitude, not a problem. This is I1 R1. Sir, I1 R1 resist to drop. I1, both will be in phase with each other. Okay, after that. Sir, where will be I1 XL1, I1 omega L1. What is I1 omega L1? Voltage across the inductive portion. Sir, what is that? Current through the inductor lags the voltage across the inductor by 90. So automatically it will be coming over here. This is I1 omega L1. If any doubt is there, kindly verify like this. Sir, remove this. Sir, I1 R1 in phase. Okay. And remove this. Sir, voltage across inductor. What is that? Current. Current through the inductor lags the voltage across the inductor by 90. Satisfied. In that way, think out. Now, sir, here. Sir, I1 R1 plus J I1 omega. J means 90. If you're taking these two, what will be the combination? If I'm taking the combination, that will be E1. If I'm taking the combination, that will be E1. Clear, guys? Okay. Sir, first one is over. Leave it. Next one. How to proceed? Kindly consider. Sir, I1 equal to I3. So therefore, I1 is equal to I3. Sir, if this vector is I3, where will be I3 R3 vector? In phase. Somewhere else you can take it. I3. But here kindly don't ask the question like, sir, how do you know I3 R3 is more? How do you know I1 L1? I don't know. Normally for understanding purpose, some magnitudes, because in the figure, do you know 5 ohms, 10 ohm, 100 ohm, 1000 ohm, etc.? No. So that's why nature based only I'm taking. Sir, I3 R3 is equal to which value? E3 directly only single element. Sir, E1 and E3, that too it is AC system, no? Vector combination. E1 vector and E3 vector combination is E. So therefore, sir, E1 vector. Like this. Sir, if you are taking this, we are going to get the corresponding E value. Supply voltage E. Clear? Okay. These two are over. If these two are over, don't say phasor diagram is over. No, not yet. Concentrate. Sir, E1 is equal to E2. Okay. E1 is equal to E2. E3 equal to E4. E3 equal to E4. Luckily, E4 is only the single branch. So directly you can write, sir, I4 R4 over. But now, sir, E2 is the combination of I2 R2 and I2 XL2. How to get it? Means you need to get I2. Where is I2? Where is I2? That is very, very important. Sir, concentrate here. This vector is, concentrate here. This vector is I4 R4 vector, E4 vector, E3 vector, I3 R3. All are same only. So therefore, this vector is which one here? I4 R4. Sir, if this is I4 R4, if this is I4 R4, where will be I4? I4 will be in phase with I4 R4. Somewhere else I'm taking. This is I4. Magnitude, don't worry, only nature. In phase or lagging or leading and combination. Sir, what is I4? I4 is equal to I2. I4 is equal to I2. Okay. Sir, if this vector is I2 vector, where will be I2 R2 vector? Where will be I2 R2 vector? In phase only. But here confusion. People are saying that, sir, you told that wherever you take, okay, I'm taking here. Sir, this is I2 R2. Okay, let it be. Sir, I2 omega L2 will be like this. I2 omega L2. Sir, I2 R2 plus I2 omega L2 is equal to I2 R2 plus I2 omega L2 is equal to which value? E2. But already we know that, sir, E2 is equal to E1. But this is not satisfying. That's why what we can write now here, E1 should be equal to E2. The two, E2 should be the combination of I2 R2, I2 omega L2 means automatically here I2 R2 should be there. Here I2 omega L2, because if you are not taking this as I2 R2 here or here, that will be changing the E2 length. That's why in order to match the E2 length, so this is what you have to take. Now in this phasor diagram, all parameters are indicated. Check it. I1 R1 J omega L1, everything is there. I3 R3 there. I2 R2 J omega L2 there. I4 R4. Now we can say, sir, this is the complete phasor diagram. But in the objective paper point of view, you don't get any draw the phasor diagram, etc. But concept is very, very important. Clear? In this step by step, you have to take. But don't worry, how to take and all. Actually, generally, I'll give the homework, but I'll give you. I'll explain here. What is that? MI bridge over. Now we are going to MICB. Not what? Maxwell's inductance bridge. Okay. This is Maxwell's inductance bridge. Same story. E1, I1. And that's why I've taken same numbers. E3, I3. Here, I2, E2. Here, very careful. This is I4 and E4 is across this entire thing. That's why everyone concentrate. Sir, I4 is coming over here. Divide into two parts. This I'm taking as IR. This I'm taking as IC. Some current. IR, IC. So therefore, IR, IC coming over here. Again here, I4 is as usual. I4 is as usual. Clear? Right. Sir, again, concentrate here. For this, we need to draw the phasor diagram. Sir, balancing conditions will be same. Why? Balancing conditions will be same. Why? Check it here. Sir, first branch, third branch, second branch, fourth branch. First, third, second, fourth. Same numbers I'm following. So automatically, yes, it will be correspondingly there. Okay. Now concentrate here. That's why I told you, if people are asking, sir, E2, I2, etc., means you missed while I'm explaining. You missed while I'm explaining. Don't worry, I will explain the second graph. You will get it. You will get it. That's why each and every step is very important. The moment I'm speaking, kindly get it. That's what the topic. Very simplest one. But as you don't have basics of phasor diagram, it may be complicated. Actually speaking, this itself is the simplest graph. Now I'm taking second one. What is that? MICB, Maxwell's inductance bridge. Sir, E1. E1, E3, E2, E4. Which bridge? Maxwell's inductance capacitance bridge. Check it. Sir, what is E1? I1 R1 plus j omega L1. I1 R1 plus j omega L1. E3. What is E3? I3 R3. I3 R3. So what is E2? E2. Only I2 R2. I2 R2. What is E4? Here be careful. E4 means people are saying that, sir, E4 is equal to I4 into R4 minus JXC4. People are giving like this. Is it correct or wrong? Everyone respond kindly once. Is it correct or wrong? Come on. Obviously wrong only. Obviously wrong. Why? It is not the series element. It is the parallel element. It is the parallel element. That's why. 1 second. Okay, stop. Very nice. Sir, now let us take now. So this is wrong. But how to write it? How to write it? Sir, I4, Z4 I have to write. So what is that? I4, R4 by 1 plus j omega R4 C4. But sir, how to draw this in the phasor diagram? What is it? R4 by 1 plus j omega R4 C4. We cannot draw the phasor. We cannot draw the vector for that. That is the reason why what we should take, not only this. See, I4 is the combination of IR and IC. Sir, voltage across R4, voltage across C4 should be equal to E4. Voltage across the R4, voltage across the C4 equal to E4. So automatically, so therefore, what we can write now? Simply voltage across the R4, IR into R4. IR into R4. Otherwise, sir, IC into XC4, nothing but minus JXC4. So therefore, what we can write here? IC into minus JXC4 means simply by omega C4 magnitude. But don't forget here, sir, I4 is the combination of IR plus IC anyway, vector combination. This is playing major role. This is playing major role. Right? Now, if you write the formula, phasor diagram is very simple. Right? Preeti, IR R4. Yes, correct. IR into IC. Come on, because IR into IC is it? IR plus IC. Constant case I'm coming again. IR into R4, IC into XC4 magnitude, and IR plus IC is equal to I4. IR plus IC equal to I4. Right? Concentrate here. These two are in parallel. If these two are in parallel, voltage across fourth branch, I'm explaining voltage across C4, voltage across R4, all are same. If any doubt is there, kindly like this. Sir, across this I have given E4, right? E4 is across this, E4 is across this also. What is that? This is R4, IR. So E4 equal to IR into R4. This is IC, this is C4, IC into XC4 or IC into IC by omega C4. That is parallel connection I gave you. That's it. Clear? Right. Because kindly go to network theory. IR minus IC, you are saying it is a parallel combination. IR plus IC only, the two I have given vector combination, no question of minus. Okay, again kindly concentrate. Phasor diagram drawing now. Sir, this is I1. For easy point of view, I'm taking I1 as a reference. Concentrate guys, no one should write anything, no one should get deviated at all. What is it? Sir, I1 R1 in phase. I1 omega L1. I1 omega L1. Okay. Combination is E1. Okay. First one is over. Clear? Same thing. There and here also same thing. Second one, I3 R3. Right? I1 is equal to what I told you. I1 is equal to I3. Sir, why? Here. I1 equal to I3. As these are same, intentionally I'm not writing every time so that you can remember, you can recollect those I1 equal to I3. Yes, sir, here. Right. I1 equal to I3. Sir, I3 is here. Where will be I3 R3 in phase? I3 R3. This is equal to E3. After that, very simplest one is, sir, combination of these two. What is that? Supply voltage E. These two are over. Okay, after that, complete balancing condition equation. Sir, here E2 and E1 both are same, E3 and E4 both are same. First write those. What is that? E1 is equal to E2, E3 is equal to E4. But luckily, E2 is I2 R2. Concentrate here. E2 is I2 R2. If two combination elements are there, you can take real part, imaginary combination. But only one element is there, I2 R2. Therefore, this vector is also equal to I2 R2. Means E2 and E1 both are same. It equal to I2 R2 in this bridge. Okay, sir. If I2 R2 is this is I2 R2 vector. Where will be I2? If this is I2 R2 vector, where will be I2? In phase anywhere. I am taking just idea purpose like this. This is I2. Clear? I2 R2 and I2 both are in phase because resistor drop and current. Sir, why only there? You can take here, anywhere. All I told you, magnitude wise, don't get tensed. Magnitude wise, don't get tensed at all. Okay, sir, this is I2. Again, go back. Sir, what is I2? I2 and I4 both are same. I2 and I4 both are equal. Okay. Now, sir, I4 is there. Okay. I4 is there. Okay. But I4 is the combination of IR and IC. I4 is a combination of IR and IC. How do you get those? Concentrate, guys. Concentrate. Sir, what is the E4 formula? E4 formula either IR into R4, otherwise IC by omega C4. IR into R4, nothing but IC by omega C4. IC by omega. Now tell me, everyone concentrate. Sir, what is this magnitude? This magnitude is I3R3 you can say, E3 you can say, E4 you can say, IR into R4 also you can say. IR into R4 also you can say. Okay, so far, come on here. If it is IR into R4, this magnitude is IR into R4. Where will be IR? Where will be IR? IR will be in phase. IR will be in phase. Sir, IR in phase with IR R4. IR in phase with IR R4. After that, sir, this magnitude is I3R3, E3, E4, IRR4 we have taken. Sir, IRR4 means IR in phase we have taken. But this magnitude is also equal to IC by omega C4. Sir, what is IC by omega C4? This is the voltage across the capacitor branch. Voltage across the capacitor branch. So automatically, voltage across the capacitor branch means concentrate here. If it is voltage across the capacitor, where will be the current through the capacitor? Leading the voltage across the capacitor by 90. This is simple network theory part. What is it here? Pure capacitance. Current through the pure capacitance leads the voltage across that. So pure capacitance. You may be saying that, so it is not pure capacitance. No, yeah, I'm talking about only this one. So pure capacitance one. That's why concentrate. If IC omega C4 means this vector is voltage across the capacitor, therefore automatically current should be leading by 90. Yes, I'm taking here current is leading by 90. This is IC. But what is that, sir? Here IC vector and IR vector both are added, should be equal to I4. Happening or not? Yes, happening. Yes, happening. Concentrate. Sir, IC vector added, IR vector added. Oh, 1 second. IC vector and IR vector both are added. If both are added, I4 vector is coming. Yes, IC plus IR equal to I4. That's what the point. That's why each and every point, if you see this tag, if you see this figure as a whole figure, definitely confusion will. That's why first vector, I'm repeating in this concentrate. I'm coming in the reverse way. Reverse way. Sir, I2 and I4. Sir, I4 vector, combination of IC and IR. IR is in phase with this one. I4 is leading with this one. So this is E4. E4 equal to E3. Leave it. And E2, I2R2 equal to E1. E1 is a combination of I1 omega L1, I1 R1. E3 directly. So automatically E1 vector plus E3 vector. Same thing. E2 vector, E4 vector also same formula. Check it. E2 or E4, E2 or E2 and E4 are E1 and E3. Both will be one and only same. That's why according to the bridge structure, yes, now you can verify each and every parameter is involved in this figure. That is called as complete phasor diagram. Clear? In this current addition is there no? Now in this voltage addition, why? Voltage across R4, voltage across C4, voltage addition. Now I'm taking the third phasor diagram. I'm going very slowly. I'm giving step by step. Kindly practice all this after the class, compulsory. If you forget to practice after the class, forget about the AC bridges completely. Not you, general I'm saying, because very, very important. Today only you have to practice. Today means tomorrow only you have to practice. That's what the point. Okay. Now again, here's bridge. Let us draw the phasor diagram. Here's bridge. Let us draw the phasor diagram. What is that phasor diagram requirement here? Concentrate. Sir, E1, I1 R1 plus J omega L1. E1, I1 into R1 plus J omega L1. E3, E2, E4. Sir, what is E3? I3 into R3. Same number, branch number I'm taking. I3 into R3. I3 into R3. Right. After that, E2, I2 into R2 simply. So therefore, I2 into R2. Sir, E4. What is E4? I4, R4 minus JXC4. So therefore, I4, R4 minus JXC4. These are the points. Again, same discussion here. Once you understand one phasor diagram, everything will be similar. Everything will be similar only. Okay, this is I1. Same discussion. Sir, I1 R1 will be in phase. I1 R1. Okay, I1 J omega L1. I1 J means 90 degrees omega L1. And combination. Sir, E1 vector. Okay, after that. Sir, I1 is equal to I3. Only we taken I1, I3, both are balancing condition. So I3 is here. Where will be I3 R3? This will be I3 R3. So this is equal to E3. Okay, after that, similar logic. Concentrate. Here, this vector is E1 vector. Sorry, E vector, supply voltage E. Right, after that, sir, what you write? E1 is equal to ET vector, E2 vector, E3 equal to E4 vector. Sir, what is E2? I2 into R2. I2 into R2. Okay, after that, sir, if this is I2 R2 vector, this is I2 R2 vector, where will be I2? In phase. So therefore, I'm taking like this. This is I2. Sir, if this is I2, where will be I4? I2, I4, both are same. Where will be I4 here? Same only. So therefore, here, I2 is equal to I4. Now the task is started. Final one. Sir, if this is I4, this entire vector is I4. So where will be I4, R4? In phase. Means you can draw anywhere. Randomly I'm drawing somewhere else here. This vector is I4, R4 vector. Sir, if this is I4, this is I4, I4, R4 will be in phase. Concentrate. I4, R4 is in phase with the I4. Okay. Now, sir, where will be I4 XC4 drop? I4 XC4 means, come on guys, I4 XC4 means, what is that? Capacitive drop. Capacitive drop. Therefore, what is it here? Current should lead the capacitive voltage by 90. If this is this one means, yes, like this. What is this? Here to here, 90. Why? This is the, what is that? I4 by omega C4. I4 XC4 means I4 by omega C4 drop. So this is the capacitive voltage across the capacitive. This is current through the capacitive, 90 degrees lagging. So finally, sir, I4 R4 combination with I4 XC4. I4 R4 combination is I4 XC4. Of course, it is not looking like a parallelogram like exactly because shape is not, because we don't know the magnitudes. That's why it is looking like, but it is correct figure only. I have not taken the perfect 5 ohms, 10 ohms, etc. magnitude. That's why this is there. That's why I4 and I4 R4 and I4 XC4 drop should be added to equal to E4. And finally, E2 plus E4 equal to E1. That's why I told you, if you are perfect, if you practice all these very much clearly, automatically all types of phasor diagrams in any subject will be clear, because in other subjects lagging only that one, but in this lagging, leading, current addition, voltage addition, combination, even equal to E2, like that, so many relations are there. That is the reason why kindly practice more and more. That's what I told you, one diagram. If you see, you will get it. You will get it. Clear? Right. Come to Owen's bridge. Come to Owen's bridge. Sir, what is Owen's bridge? Here, concentrate. E1, I1, R1. I1 into R1 plus j omega L1. E1, I1 into R1 plus j omega L1. E3, E2, E4. So what is E3? I3, R3. Sir, what is E2? I2, R2 minus JXC2. I2 into R2 minus JXC2. Sir, what is E4? I4 into minus JXC4. I4. JXC4, no, minus J. So simply I4 by J omega C4. Magnitude means only this you can take. No problem. Clear? Right? Okay. Now, this is little bit confusing to people, but same thing only. Only the confusion means you are missing lagging and leading concept. That's it. Sir, I1. Here, I1 R1. Here, I1 omega L1. Same thing. Now, sir, combination of these two. What is that? E1. Same thing. Leave it. After that, sir, I1 is equal to I3. Concentrate guys. I1 equal to I3. Okay. So if I3 is here, I3, R3 will be there. That is equal to E3. That is equal to E3. Sir, finally, E1 plus E3 combination is equal to E. Okay, first task is over. Here people are unnecessarily confused because only single element capacity is there. No, small doubt, but very simple. Sir, E1 is equal to E2. E3 is equal to E4. Okay, sir, what is E4? Single element, always take it first. E4, what is that? I4 by omega, so magnitude. So therefore, I4 by omega C4. Sir, this vector is capacitive drop vector. Why? I4 by omega C4. Sir, where will be I4 vector? Where will be I4 vector? I4 should lead this value. So therefore, I am taking here. This is I4 vector. Sir, I4 leads the voltage across the capacitor by 90 degrees. I4 vector. Sir, what is I4? I4 is equal to I2. Sir, where will be I2 R2? Concentrate guys. Where will be I2 R2? Concentrate, very, very important. Where will be I2 R2? In phase with this one. In phase with this one. So therefore, here I'm taking. What is this? This vector is I4 R4 because I4 R4 in phase with, sir, 1 second. I2 R2. I2 R because I2 R2 in phase with I2. I2 equal to I4 already there. Okay. Now, sir, if this is I2, nothing but if this vector is I2 vector, sir, where will be capacitive drop? If this vector is I2 vector, where will be capacitive drop here? Lagging by 90 here. Current will be leading. But be clear, sir, if this is I2, this vector is I2 vector. If this vector is I2 vector, I2 R2 will be in phase, okay. But where will be the voltage across capacitor? That C2 means 90 degrees behind 90 degrees lagging. But sir, where we have to take? Here we have to take, or here means be clear. We need to take here only. Here only. This vector is I2 by omega C2. Sir, why? Means concentrate here. Sir, everyone concentrate. Sir, I2 R2 vector and I2 XC2 vector, if you're adding these two, you should get E2. Sir, I2 R2 vector, I2 XC2 vector added, that is equal to E2. In that way, you have to take it properly. This is what the complete picture regarding. Yes. Clear? What people are thinking, sir, here it will be there I2 by omega C2. This is VC2. Come on here. VC2. This is I2. I2 is lagging the VC2. I2 lags the VC2. Wrong. I2 should lead the VC2. So therefore, VC2 should come over here only. This is the total discussion regarding all types of phasor diagrams. Actually, I will take every time one or two. I'll give the homework only, but anyway, you're asking many doubts. So that's why I clarified all the phasor diagrams. That's why after this session, definitely you have to practice. What is that? First I1, I3, I3 R3, E3, and then I1 R1, I2. What is that? I1 omega 11, E1, E1 equal to E2, E3 equal to E4, like that, completely step by step formula and balanced condition. Both you have to take and both must be continued. Clear? So this is a total discussion regarding all four bridges in detail explanation. Can you respond? Yeah, easy, but must practice. Definitely. The moment I'm drawing, okay, this is here. Okay, that is there. Okay, this is here. Like that will be there. But you need to draw on your own. But my question is, do you understand or not? That's it. After that, practice this and you will get it. No problem. Right. Right. Very good. Other people? Yes. Definitely. You have to practice definitely. Okay. Now the fifth bridge. That is Anderson's bridge. Anderson's bridge. So what is this Anderson's bridge? Very simple. Concentrate here. Here, this is R and L. R1, L1. This is R3, right? This is R2. And this is R4. Simplest bridge he has given. But what he proposed, he proposed the bridge with internal branches, contact branches he has considered. But except this branch, in all these branches, have you considered any contact drops? No. In this also, no contact drops. In this also, no contact. That's why only in Anderson he proposed. Why? No, they propose. We will take. That's why only in this bridge they have proposed. What is it here? Internal drops. Sir, in transformer phasor diagram, you said current phasor and IR phasor should not in same. When did I say? Kindly go back and see that. Right, sir. In this, what is it here? Contact drops. Contact drops he has considered, but how he has given means this is the galvanometer. And here resistance is given. Here capacitance is given. These two are related to internal drops related. Now tell me, as internal drops are being considered, now this bridge is highly accurate or less accurate. First point, everyone, internal drops are being considered. So therefore, the bridge is highly accurate, less accurate means highly accurate. All I told you in the KDB concept. What is it? If internal drops are considered, the bridge will be automatically highly accurate. Yes, very good. Plus, sir, if the bridge is highly accurate, low values can be measured properly or not? Yes, low values can be measured properly. That's why Now I'm going back to the starting topic of this here in this measurement of inductance, not only inductance but also quality factor. Sir, what is the quality factor? General range Q less than 1, low quality factor, 1 less than Q less than 10, medium quality factor, Q greater than 10, that is high quality. This is the range. Just like resistances we have divided, no, low resistance, medium resistance, high resistance, etc. Same notation. The quality factor is also categorized. Q less than 1, 1 less than Q less than 10, Q greater than 10. But sir, without having any second thought, with which bridge we are able to measure low values properly? Highly accurate bridge. Which is a highly accurate bridge? Anderson's bridge. That's why, be clear, the low quality factors are possible. Low quality factor measurement is possible only with Anderson's bridge. With this one, no quality factor at all. With these three bridges, we cannot get the low quality because all I told you, in each and every bridge, contact drops are not being taken. Not that much highly accurate. Therefore, low value quality factor is not possible. Second one, here, contact drops are not considered. Contact drops are not considered. Contact drops are not considered, but contact drops are considered. All I told you, contact drops are considered automatically. Small values also are considering means, yes, small values we can measure. That's why the low quality factor measurement is possible with Anderson's bridge. This was the first observation. After that, simple mathematics only I'm going to take now. Right now, here also same thing. Concentrate, guys. Concentrate, sir. What is that? This potential is equal to this potential. What is that? What is a galvanometer equal to 0? This implies which one? VC is equal to VD. Sir, VC equal to VD. If you open this, right? Did you understand KDB derivation yesterday? We have taken no current division law, etc. Here also same thing. Current is coming here, divided and apply the current division law. Get the VD, get the VC and proceed. Get the VC and VD and proceed. You will get the corresponding equation. I'm giving this as a homework, but other method is there that I'll be taking. Kindly concentrate. Don't think like I'm giving too many homeworks today. No, this is simple mathematics. We have taken so many times that mathematics already in the class. That's why I'm giving this as a practice. And you need to find out R1, L1. By which process? Yesterday we have taken no KDB. Listen, no, VC equal to VD and proceed the equations, etc. If you do like that, you will be getting. But my way is other method I will explain, because in the other method some concept is there. I will give that method, but very simple method only. It is also very simple. I'm not giving these, don't worry. I will be taking the other method. I will be giving the answer over there. That is what many people applied the delta to star conversion in the yesterday's question. But I told you, before balancing, okay, you can apply, but after balancing you should not, I told you. But generally balancing technique is only our topic. That's why I'm taking balancing technique only, the first method. But idea purpose, clarity purpose, some other method also I'm taking now. Sir, what is that? Concentrate here. So many times I will draw the figure. Kindly have the patience to listen. R1, L1, here R3, here R2, here R4, galvanometer, resistance, capacitance. This is R, this is C, supply is here. E. Okay, very important. Sir, these three are in star. I would like to convert this star into delta without balancing only. Before balancing only I'm doing. So therefore I'm making these three into star. You can. So therefore concentrate. After replacing this star, how will be the delta? That is many. That is playing the major role. Sir, this is the star. How will be the delta? 1, 1 and 1. Okay, but sir, this is a star. No, this branch I'm keeping here. This branch I'm keeping here. Still it is star only. Still it is star only. How the delta? This branch I'm writing here. This branch I'm writing here. Bottom branch I'm writing here. Means you should be perfect in the network theory. Star, delta, delta, star, delta to star. Connections also compulsory. Clear? Okay. I'm drawing this one. Concentrate here. I'm drawing with dotted lines like this. One branch. One branch. One branch. Okay. Right? Now, after this star to delta, we need to have the conversion formulae, but few people did not complete with network theory. So kindly consider, I'll give the formula. Take it once. Take it for granted. Okay, now, sir, this R1, L1 as it is, this R3 as it is, R1, L1, R3 as it is. Here, now, concentrate here. Here, supply as it is. This is E, okay, and concentrate here to here, one resistance. So therefore, this is one resistance, and this is one resistance. Here, capacitance is there, and this is one resistance. Between these two, galvanometer is there. Between these two, galvanometer is there. Clear? Means simple logic here. I am removing this entire star branches. After replacing the star with delta, star branches should not be shown. That only I have drawn. But step by step, I'm drawing many. What I'm doing, sir, I'm holding this point. I'm holding this point. I'm pulling downside. What will be there? Concentrate. Sir, R1, L1, R3. No change here. R1, L1. Come on, guys. I'm holding this point. I'm pulling downside. What will be there now? If I'm pulling, galvanometer point will be coming like this. Means this point, just I'm simply pulling like this, wire pulling. This is one resistance. One resistance. Okay. And this is one resistance and capacitance. Okay. And this bottom one is in, that is one more capacitance. Sorry, one more resistance. Finally, supply voltage. Simply I'm taking delta to star conversion, that's it. But sir, this is C. Okay, but sir, after having the delta to star, what is the formula? I don't know whether you remembered or not. Be clear. This resistance formula is nothing but between these two resistors, we are adding this resistor. Therefore, the formula, those who are not done with the network theory, don't get confused. You will get that. You will get that. Ravi Teja, kindly go back to the recorded video. Why I'm taking this, you can get the idea. That's why I told you. This is the main problem. Sir, in the homework question, you told that don't apply delta. Sir, why are you taking delta? I told you that already. I told you that before balancing, you can apply. That's why you can take before balancing. But after balancing, you should not take. I told you in the homework question. Same concept I explained. First, I followed balancing condition only. But one more method is also there. Before balancing, Ravi Teja, kindly don't sleep. Before balancing, I'm taking, we can take that only. I told you. That's why I'm saying every point must be listened carefully. Listen carefully. Otherwise, you told that not to take, you are taking here, and unnecessary controversy will be there. That's why you can, after that, you cannot understand the next topic. That's the main problem. That's why I told you, this is the ultimate process. But other method is also there. I did not balance. Here, balanced is done over. But in this method, I did not balance so far. That's why I'm taking without balancing. Clear? But this is only concept explanation point of view I'm giving, but actual topic is this only. In the conventional paper point of view, you need to follow this only. But my duty is to inject the topic in more better way also. That's I'm giving second method. That's I'm giving second method. Clear? Right. Now come back. Sir, what is this value? Concentrate, guys. R2, R4 in between you're keeping. No, kindly concentrate. This value is R2 plus R4, R2, R4 by R. How? That is delta to star conversion. And this one, what is this? R and R4 combination. R plus R4 plus R into R4 by R2. You must be knowing star to delta, delta to star formula compulsory. Clear? Right? Okay. First method. This is second method. At least. Okay. Now, sir, concentrate. This resistance value, what will be there? What is it? R2, R4 combination. What is it? R2 plus R4 plus R2, R4 by R. But now question is, sir, whatever may be this value, does it affect the balancing condition of the bridge? Whatever this value, does it affect the balancing condition of this bridge? Is it affecting the balancing condition of the bridge? No way. Sir, why? What is my question meaning? Concentrate. Sir, 5 4s are 20, 10 2s are 20. Some supply is given here. Some galvanometer is there. Is it balanced or not? Balanced. Suppose if I add 100 ohm, is it affecting this balancing condition? Never. Except 0 or infinity. Of course, infinity no problem, except to 0. If it is infinity, you're opening. 0 means some shortcut notation, etc. That's why finite value only there. Under that condition, this resistance does not affect the corresponding circuit balancing. That is the reason why. What I'm saying, concentrate, guys. That is the reason why I'm neglecting this element effect. Under which condition? Balancing condition, not normally. Only under balancing condition I'm taking. One second. Yeah, here small. Right. People are having doubt. I'll explain here, sir. R4 combination, R2 combination, R. Okay. One second. I have written in the reverse here. Consider here. This is R and R2 combination. Yes. R plus R2 plus R2 by R4. Here R2 R combination, R2. Here R4 combination, R plus R4 plus R4 by R2. This is other branch. Okay, I have written this corporate. Okay, correct. Right now this can be eliminated. Sir, if it is eliminated, if it is neglected, everyone, this bridge is similar to which bridge? Come on, guys. This bridge is similar to which bridge? If you neglect this bridge is similar to which bridge? So far we have taken 4 bridges. Among those 4 bridges, this is similar to which bridge? Come on. This is similar to which bridge? Everyone. Very good. Maxwell's inductance capacitance. I'm going to that concentrate. In the Maxwell's inductance capacitance bridge, see that RL. Okay. Single R. Single R. Here also single R. Value is but element I'm saying. Here RC parallel. Here also RC parallel. That's why this is similar to which one here? Maxwell's inductance capacitance bridge. Sir, now with the simple shortcut, sir, this is MICB. Nothing but similar to. Sir, in MICB, what is the corresponding formula of this is anyway unknown. We are not changing this unknown. What is the formula? R1 is equal to R2 R3 by R4. L1 is equal to L2 R3. One second. R2 R3 C4. Already we have got it. Check it. R2 R3 by R4. R2 R3 C4 we have taken. Clear? Okay. Now the question is, sir, from the which one? MICB. Now I'm writing in Anderson's bridge. In Anderson's bridge. Simple shortcut based I'm writing. Direct answer will be there. Direct answer. This is only extra explanation I'm giving. Otherwise, I can give this answer directly here only. Over. Take the mathematics. But I'm explaining other procedure also. Concept point of view. Here. Everyone keenly observe. Sir, this is first branch. Okay. This is first branch. Same thing. Sir, this is third branch in the MICB. Yes, third branch. Same single element. But what is the change, Sir, here single branch, okay. But R2 alone. Here, single branch, okay. But this is the combination. That's why very simple. Yeah. R1 formula I'm writing. Kindly observe. R1 formula equal to R2 in which branch? Which branch? MICB. Sir, what is MICB? This branch value. But in our Anderson, this branch value is this total value. Are you able to understand here? That's why I'm writing first branch, third branch, second branch, fourth branch number. Second branch resistance is in the place of this. We have to write. What is that? R plus R2 plus R2 by R4. Okay, next. R3. R3 means third branch. In our case also, third branch is same single R3. Same single R3 by. Sir, R4 means fourth branch resistance. Sir, this is the fourth branch. I give this is the resistance. R plus R4 plus R4 by R2. This is the formula of R1. You will get same formula here. You should get. For verification purpose, I am explaining this one. Clear? Still confusion. Concentrate. L1. Sir, this is in MICB. In MICB, second branch resistance. In Anderson bridge, second branch resistance. That you have to take. Simply R plus R2 plus R2 by R4. So in MICB, third branch. In Anderson also, same third branch, single element only. Sir, R3. In MICB, what is it? C4, fourth branch capacitance. Anderson, fourth branch capacitance is just C. Yes, this is what the point means. Why I have taken this entire approach, we can understand that in the ESC objective questionnaire, in the PSU examinations generally, and in the gate also, chance is there. Anderson's bridge is the modified form of which bridge? Anderson's bridge is the modified form of which bridge? Means Maxwell's inductance bridge. Anderson's bridge is the modified form of which one? Maxwell's inductance bridge. Clear? Right. Vishnu Ajit Sai, why resistor neglected, sir? Last network. Kindly go back and listen the recorded video. Kindly listen this. Because I explained this much, very lengthy topic. Example also I have taken. Why I have neglected, I told you. Kindly go back and watch the recorded video. Okay, so this is the complete discussion regarding all the bridges. Right? Same thing. You can take star to delta, delta to star, etc., etc. No problem at all. But this is only mathematics. We are not operating this practically. This is only operated. Don't get confused like, sir, in this method where you are balancing, this is not balancing procedure at all. This is not balancing procedure at all. That is reason why this is only the normal procedure. Actual procedure is this only. But star to delta practice purpose, and I need to give that Anderson's bridge is the modified form of MICB. For that purpose, I have taken. Otherwise, finally, I'm going back again. Sir, if resistance R is equal to 0, in which bridge? In this bridge. Come on here. It is variable, varied, and equated to 0, for example. This is equated to 0. If it is equated to 0, short circuit. So if it is short circuit, this potential here or here or here, no problem at all. Means I'm erasing this. I can draw here also. If R equal to 0, come on guys. If R is made 0, this bridge is not similar to MICB, exactly equal to MICB. Are you getting my point or not? I'm coming again. If R, as the R is variable, if R is made 0, this bridge is exactly equal to MICB. Not only similar to MICB, no, exactly equal to MICB. Are you getting the point or not? So therefore, concentrate here. Sir, I'm going the reverse way. If R is equal to 0, sir, R1 is equal to R is 0. R is 0. Numerator R2, R3 only. R2, R3 only by R is 0. R is 0. Denominator is R4. Sir, if you verify this, exactly equal to this one. So therefore, if R is equal to 0, then Anderson bridge is exactly equal to MICB. Yes or no? Yes, this is what the reverse way proof I'm giving. That's why Anderson bridge is the modified form of MICB. In the same way, L1 equal to under R equal to 0. Sir, why R equal to 0 means R is a variable. We can make 0. That's our wish. And here, R is 0. R is 0. R2, R3C. R2, R3C. Check it. R2, R3. Their fourth number here, simple C. So therefore, yes, whatever the assumption we have taken, neglected assumption, yes, working properly, perfectly valid, perfectly valid. So this is the total discussion regarding entire, what is that? Self-inductance bridges. Self-inductance bridges. Clear? Right. Right. Concentrate, guys. Few people are asking you to explain star delta. Kindly, you need to be perfect in the star delta. That too, I'm saying you don't mind. You don't mind. Being a BTech student or completed or fourth year or third year, second year, before coming to the ACE coaching, network theory is completed in your college. Okay, sir. College generally you forget. No, you forget everything. But KCL, KVL, nodal, mesh, Ohm's law, star delta, you should not forget. You should not forget. That's what the point. But don't worry, I will explain this entire star delta formula again. Formula, nothing here. That formula I have taken. That's it. Right. Bhavani, after converting star and delta, finally, here I'm taking, assume that balancing condition, but actually speaking, in order to take the balancing, variable R is not there. You remove the variable R. That's why this is not the practical concept. This is only mathematical concept. That's why one student already asked, sir, in this second method, where you're balancing, I'm not taking that simply. I'm simply saying that both are equivalent notation. I'm repeating, this is only the actual concept. This is only the actual concept. In this method, where we are balancing, we cannot say why. Why means R is there. R should be there already. But we have modified that R. Where is R variable element to get the balancing? Not. That's why this is only for saying that MICB and Anderson both are similar. For that purpose, I have taken. Right. Clear, guys? Right. This is a total discussion regarding the entire topic of which one here? All 5 bridges. Okay. After the break, I'll come back. I'll conclude all the 5 bridges with a note. We'll be going for the capacitance measurement. Clear? Take the break and come back. Right. So this is the total discussion regarding all the 5 bridges. See, that's why I told you, kindly concentrate in this entire method. In the second method, I'm not at all saying that which is bridge, balanced or not, etc. No, similar to that bridge, structure wise similar to that bridge. That's why I've taken the equation. But this is the actual thing. You're not understanding my English. Kindly consider this is what the actual bridge procedure balances happen. And based on this only, you derive it. But what is the answer means? In other way I gave you, you will get the same answer. No need to worry. Right? Now, finally, concentrate here. Finally, kindly don't leave the session. I'll be discussing about, I'll be giving the information about next class schedule. Tomorrow is a break, right? I'm giving now only because people are leaving now. See, tomorrow is a break, right? Day after tomorrow, for instrumentation people, 7 to 9, 7 p.m. to 9 p.m., right? Electronic measurements. But electrical people, that will be uploaded or updated in the portal. Kindly see the portal. It will be updated by the end of this session today. If the information I receive, I'll tell you. Otherwise, okay. But people have one doubt, small doubt. Sir, in the electrical measurement today it will be completed. Means today bridges will be completed. Some other topics also, small topic will be completed. But only revision part I told you, and extra questions and only small topic may be left over. I'll be taking that on Sunday. Electrical measurements will be continued. Electrical measurements pending part. Clear? Which one? Nandakumar from 6:30 a.m. Which has come tomorrow? Is it tomorrow or at which time? 6:30, not 9:30 a.m. Schedule has come. My subject, electrical measurements. Electronic measurements for electrical students. Did you receive that, Abhijit? Did you receive them? Did you people receive that electronic measurement schedule? On Sunday, 9 a.m. to approximately 2.5 hours required. 9 a.m. to electrical measurements pending part. It will be completed. CRO is there in the electronic measurements. That's why before asking the question, try to know the syllabus first. Electrical measurements tomorrow 9 a.m. for electrical students. Did you get that? One second, be online. Kindly see that clearly. See that is it on 20 or on which date? Kindly see that. That's what. Don't confuse. Don't confuse me. Because just now, yes. Very good. On 20. Okay. Hello, Venkat. I am there. 9 a.m. Okay. Let us not waste the time. Kindly concentrate. On Sunday, 9 a.m. to 11:30 or 10:30, etc. time will be there. That is electrical measurements pending part. Only small topic will be there, and rest of the what is it? Revision type will be there. Otherwise, today it will be done actually, right? One second, one second, one second, one second, one second. Okay, 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 okay. You're messaging continuously for the. Okay, okay, right, 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 right. Actually, I forgot. See, concentrate here. Yes. Okay, okay, got it, got it. Sorry, sorry. Right here, experimental results. I'm giving here experimental results. Right. Sir, experimentalism means Maxwell's, Hayes, Owens, etc. All those people, right? All those people experimentally given one result that I'm giving as a note. Other than this complete concept, mathematics, everything you've taken, these are the experimental result given here. In the Maxwell's, what is the quality factor? Omega R4C4. Omega R4C4. Yes, with this, which type of quality factor we can measure means experimentally they gave that medium quality factor 1 less than q less than 10 quality factor is given. Clear? After that, Hayes bridge is used for measurement of q greater than 10. Hayes bridge is for q greater than 10. Owens bridge is for 1 less than q less than 10. Owens bridge is for 1 less than q less than 10. All these are experimentally given. Don't get confused. And finally, Anderson's bridge. Sir, already told you, Anderson's bridge is q less than 1, but also Anderson's bridge is similar to when r is equal to 0. Anderson bridge is exactly equal to Maxwell's inductance bridge, so that q less than 1 and 1 less than q less than 10. So all these are the experimental results they give. But for this explanation also I gave you mine. In this, contact drops are being considered. Contact drops are being considered. Therefore, automatically, what is it here? Q less than 1 is possible. Low value is possible. So other things are experimentally given. Nothing more than that. Kindly be clear with the terminology. Clear? This is a total discussion regarding entire inductive bridge, that is self-inductance measurement along with that quality factor measurement. Okay. Now let us take the next topic. Measurement of capacitance. Measurement of capacitance. So what is this measurement of capacitance? Right, concentrate. Measurement of capacitance. Sir, in order to measure the capacitance, right, we are having two types of bridges. One is de Sautis bridges. De Sautis bridge. And second one is sharing bridge. Sharing bridge. But if you see a few textbooks, it is given like, sir, second one is modified de Sautis bridge. Modified de Sautis bridge. Right? That is inbuilt only, but I'm taking separately. Third one is sharing bridge. These are the three bridges available. But sir, in this capacitance, what I told you, which type of factor will be determined? I told you in this type of thing, which type of thing will be determined here? Right, okay. Anderson's phasor diagram is homework. Anderson phasor diagram is homework. Clear? One second. Few people ask, sir, earlier you gave Owens bridge Q greater than 10, now Owens bridge 1. Jitender, when did I give earlier? Jitender, when did I give earlier Owens bridge is Q greater than 10? Can you let me know? Jitender? Jitender, in the beginning, where did I give? Come on here. This is this. This is this. What about this one then? Come on, come on. Have the minimum common sense. We can say this is the quality factor. Separate ranges I gave you. This is the quality factor. Separate ranges. I have given like this, etc. Here. No way. This is only the range of quality factor. Range of quality factor. That's why be clear. Be clear. Before asking the question, kindly think once. Think once. Yeah, that's what. Pratik, yeah, very good. Thank you for supporting. Thank you. Right. Sir, of course, if I write here also, you may be thinking like that only. In the capacitance, we are going to find dissipation factor. Dissipation factor. What is the formula of dissipation factor? D is equal to omega RC. This is the general formula of dissipation factor. Can you don't take like this, sir? Sharing bridge dissipation factor, modified shading bridge D equal to omega RC. Sharing, what is it? Modified D. So it is sharing is not there. Or come on, don't think in that way. Concentrate. These two are separate. Simply dissipation factor formula I am giving. That's it. Clear? Right. Now, be clear, guys. Sharing bridges generally for pure capacitance only. Whatever the this out is bridge. This out is bridges generally given for only this out is bridges generally given only for which one? Pure capacitances only. Sir, pure capacitance is possible practically? No. That is the reason why modified form is there, and then sharing bridge is also there, just like different types of bridges available. But very, 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 very simple. Yeah, this out is bridge is simplest bridge. First one. This out is bridge. This out is bridge. Very simple. Same thing. Bridge will be like this, right? Here, capacitance. What is this? This is unknown. People may be asking that. That's what I told you. Sir, capacitance means unknown capacitance. How can you give only C1? It will be having some last component, you know. Yes, it will be having last component. But this out is bridges only for pure capacitance. Means it is only conceptual purpose, not for practical approaches. Okay. And here, this is R3. Here, this is C2, and this is one more R4. Simplest bridge among all the bridges is this only. This is the galvanometer. Okay, right, sir. Mathematics. Kindly concentrate. Mathematics. What is it here? Sir, Z1, Z4 is equal to Z2, Z3. Z1, Z4 is equal to Z2, Z3. Sir, what is Z1? Minus J x C1. Minus J x C1. Z4, R4. Z2, minus J x C2. Z3, R3. Simply minus J cancel. XC1 means 1 by omega C1 R4, 1 by omega C2 R3. Again, omega cancel. So therefore, what is the value now? 1 by C1 into R4 equal to 1 by C2 into R3. Okay. Therefore, C1 is equal to R4 by R3 into C2. Very, 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 very simplest bridge. Very, very simple bridge. But my question is, sir, what is the dissipation factor in this? Can anyone give? What is the dissipation factor in this? Everyone, what is the dissipation factor in this? What is the dissipation factor in this? Very nice. 0. Why? Why 0? C1 is there. R1 is not there. Why? It is a pure capacitance. Therefore, last component, dissipation component is not there. Completely 0. Yes. Dissipation factor is 0. Yes, as pure capacity. Very good, very good. So therefore, no need to comment anything. Okay, right. Now, sir, this is only conceptual part, but our topic is which one here? Correspondingly, practical measurement also to be possible. So what is a practical measurement possibility means? Modified de Sautis bridge. Modified de Sautis bridge. Very simple. Instead of taking the pure capacitance, he has taken practical capacitance R1, C1, R3, R1, sir, R and C, and here R4. Sir, R1, C1 automatically which one here? Unknown. That is practical only because C1 its last component, so that practical only. This is R2, C2, R4. Supply. What is it? E. Here, gallanometer. Right. Everyone, take 2 minutes of time and simplify and tell me the value. Z1, Z4 equal to Z2, Z3. Simplify and tell me R1, C1. This is not homework. Now only you have to give the answer. Now only you have to give the answer. Make it. Come on. Very nice. Very nice. R1 equal to R2, R3 by R4. R2, R3 by R4. What about C1? R4 by R3 C2. Very nice. R4 by R3 C2. Now in this, sir, what is the corresponding variable element? Same shortcut applicable here. See, R3, R3 same, R4, R4 same. So therefore, R2, C2, uncommon. This is only shortcut here. Where it is possible, I'm showing. Otherwise, you need to follow the bridge given by them directly. Of course, many people give the correct answer. Yes, very good, very good, very good, very good. Okay, after that, what is the dissipation factor D? Omega R1 C1. Omega. What is R1? R2 R3 by R4. R2 R3 by R4. C1. R4 by R3 C2. R4 by R3 C2. Simply R4 R4 R3 cancel. Dissipation factor is omega R2 C2. This is what the formula. Clear? Clear, guys? See, this mathematics will be clear only, but my problem here is after the class, if I say sharing bridge means you must be able to draw the sharing bridge compulsory. And Anderson bridge means you must be able to draw the Anderson, practice in that way. Now, finally, sharing bridge. This is very simple. Inductance bridge is only somewhat lengthy, etc. That in the capacitive bridges, phasor diagrams are not required. No need to worry. I'm not skipping. Kindly, this is the main problem here. Generally, my topic is always at the end of the session only. I'll be taking bridges, but people are thinking that sir is in the hurry mood, etc. No, yeah, I'm leisurely, clearly, step by step explaining. I'm not missing anything. Generally, I don't skip anything. No need to worry. I don't skip anything, no need to worry. Right? Nikhil, is it R3 by R4? Or R4 by R3? Check it. It is R4 by R3 only, it seems. Kindly check it. 1 second. Yeah, correct only. This is correct. It is correct only. Kindly check it. Right. Okay. Next. Scaling bridge or sharing bridge, as you wish. This is generally popularly used because this is not the actual bridge. This is simply modified bridge. This is not the actual, only modified. So that's why popularly used bridge is generally sharing bridge only. Right? Now, concentrate here. What he proposed in this R and C, R1, C1. Right? And here, this is R3. This is R2. 1 second. This is C2. This is R and C. R4, C4, and here this is the supply. Kindly, you must be able to draw like this just by seeing the name, but that is not that much easy until unless you practice more and more today or tomorrow morning. Don't postpone it. Kindly don't postpone it. Anil Kumar, it is not R3 by R4 here. I verified it is R4 by R3 only. Right. Aishwarya, very good question. I'll tell you. In the inductor, quality factor we define. In the capacitance, we define dissipation factor. In the inductor, we don't define dissipation factor. In the capacitance, we don't define quality. That's why quality word itself is suitable to inductive function, magnetic function, and dissipation factor is for which one here correspondingly capacitive functions. That's I wanted to give later, but okay, no problem. Everyone don't get confused. Quality factor we are not defined, not like that here. In the capacitive structures, dissipation factor only we define. And in the inductive structure, only quality factor we define. That's what the terminology based notation. Okay, now here, sir, Z1, Z4 equal to Z2, Z3. Z1, Z4 equal to Z2, Z3. Sir, what is Z1? R1 minus JXC1. Z4 R4 by 1 plus J omega R4 C4. Z2, what is that? Minus JXC2. Z3 R3. Everyone, simplify and tell me the value of R1 and C1. I'm making you to practice in the class itself. Kindly do this. Don't copy everything. Yes, very good. Quality factor means quality of inductive material. Dissipation factor means how much dielectric loss is there in the capacitance. That's what the point. Dissipation means loss. How much dielectric loss is there in the capacitance? That is dissipation factor. Give me the value kindly. Have the derivation take 2 minutes of time. Come on. Very nice. Yeah, this much. This is the fastness. Very good. What is R1? C4 by C2 into R3. Correct. C1 R4 by R3 into C2. Okay, many people give the correct answer. I got the schedule for electrical people also. I will announce it. No need to worry. At the end of the session, I'll announce it. No problem. My sister, you asked no. Yeah, I'll announce. No need to worry. Just now I got it. Fine. So this is what the thing. Now, so same procedure. R3 same. R3 same. C2 same. R4 and C4 are uncommon. So automatically variable. So therefore, R4, C4 are the variable elements. Clear? Right? Now, in this again, dissipation factor. Dissipation factor. Right. I would like to give one more formula. Dissipation factor omega RC I gave, actually we can also write like this. Dissipation factor D equal to, in your normal basics, you might have known that tan delta is equal to omega RC. D is dissipation factor. Tan delta, delta is dissipation angle. Dissipation angle delta. Omega RC is elements only. In the question, any formula may be given. Right? Now here, dissipation factor D is equal to, just for clarity purpose, tan delta equal to omega R1 C1. Omega, what is R1? C4 by C2 R3. C4 by C2 R3. What is C1? R4 by R3 C2. R4 by R3 C2. R3 R3 C2 cancel. So therefore, dissipation factor tan delta equal to omega R4 C4. This is what the total discussion regarding all the bridges. Completely today's total topic is completely mathematical topic only. Only little bit concept is there, but majorly mathematical notation only. Right? Now, this is the total discussion regarding measurement of inductance, that is self-inductance, thereby quality factor, and measurement of capacitance, thereby dissipation factor. Just answer once. Is it clear or not? So far, what I have taken, clear or not? Respond kindly. Very nice, Hema, very good, very good. Yeah, now I'm giving that only. Many people are waiting for this. Many people are waiting for this. Many people are waiting for this. How to get all these? How to get all this? Yeah, that's what I'm saying. Definitely, variable elements are coming in dissipation factor. Variable elements are coming in quality factor also. In the quality factors, you'll be getting variable elements in the corresponding thing R2C2 variable only. That is a simple logic, right? Now, I'm giving simple technique to follow that, but you need to practice simple logic. Yeah, nothing to worry. Nothing actually is not difficult. But the moment you're thinking these many are there, that is a negative thought. Simply what you have to do after going home, concentrate here. Right. No, sir, I have some queries. Right. Okay. Right. Here, concentrate. Concentrate here. First, after going home, take one notebook, rotate that notebook like this. Simply 5 columns you make it. What are the names I gave you? Maxwell's inductance, capacitance, Hayes, Owens, Anderson's. Like that you make it. After that, simple logic. Just by saying that, okay, in all the bridges, first branch is unknown. First branch is unknown. After that, see that, yeah, what is the third branch? Like this. What is the second branch? If you draw like this by comparing one by one, automatically you will get the thing. But don't study them separately, but in order to have the complete logic, study them in the comparison way only. Just if you see like, okay, this is the chain, this is the chain, in that way you need to compare. Automatically you will remember, definitely. But this order you follow, I follow this order. No, you follow the other way, you can anything. But if you follow, so, okay, MIC means second bridge means, okay, this is a change from here. Okay, in that way, you need to draw the diagram. That's why MICB, Hayes, Owens, Anderson, that logic. Otherwise, as you wish, according to your names, etc., you can practice anything. If you follow in this way, automatically, just only 10 to 15 minutes is more than enough. Take the notebook, what are the thing I have taken? First, draw the 5 times by looking at, or then observe it. Okay, this is same, this is same, this is same. Okay, this is different. Okay, from here to here, here to here, this is the difference. In that way, automatically, you will remember. Why I have drawn it in the class 2 minutes? That is only I have done. Same logic I follow, same thing I'm giving. Right? Clear? And then we correct. And same thing, 3 more columns. What is that? D Sautis, modified D Sautis, sharing bit, same notation, nothing more than this. Nothing difficult actually. Compared to, I can say openly, Bridges chapter is the easiest chapter compared to other chapters. Strictly speaking, this is the easiest subject actually, easiest topic actually. But this much of mathematics is there. No, people are poor in the KCL, KVL. People are poor in the R plus JXL, R minus JXC, polar to rectangle. That is the reason why this topic is looking like very difficult. Other than that, otherwise very, very simple. Clear? Yes. Right. Now I'm taking next measurement in this. Measurement of frequency. Measurement of frequency. Clear? So what is this measurement of frequency? Which bridge is used? Means Wien's bridge is used. Very, very, very popular object question. Which of the following bridges used to measure the frequency? Which of the following bridges used to measure the frequency is the very, very, very popular bridge. Right. In this bridge, what is the construction? Concentrate here. This is the general shape of the bridge. R like this. R3. R2, C2. This is R4. Now, come on, guys. Now tell me, among these 4 branches, which is the unknown branch? Everyone should respond for this. Among the 4 branches, which is the unknown branch? Come on. Among the available 4 branches, which is the unknown branch? Come on. Right. Be clear, guys. This is the main problem. You are not concentrating. Concentrate here. Very good. Very good. See, so for that purpose only asked, see, many people are saying that, okay, so far sir has taken left to top. So therefore, RC branch is unknown. They are saying, come on here. What is our unknown parameter? Which is unknown parameter here? Frequency is unknown. Only few people gave that. Sir, unknown branches, not there. Out of 4 branches, 4 are known. 4 are known. Out of 4 branches, 4 are known. Intentionally, I have not written R1 and 7. Okay, sir has not written means something is this. Come on here. So far we measured self-inductance. So far we measured, what is it? Capacitance. That's why one branch element is variable. But our topic, which is variable here, frequency is variable. So therefore, automatically frequency is unknown. Nothing but all branches are known values in this Wien's bridge at any cost. At any cost, all the branches are known. Don't think like, sir, one branch is not given. Come on here. 2 unknowns in the single equation, not possible. Therefore, frequency is unknown means the branches will be, should be given definitely. Right? Okay, now very simple. Sir, in this I will do the mathematics. Small point is there here. Z1, Z4 equal to Z2, Z3. What is Z1? R1 by 1 plus j omega R1 C1. Z4 is R4 equal to Z2 R2 minus j, otherwise simply R2 plus 1 by j omega C2 into R3. Clear? Just multiply here. What will be there now? If you take cross multiplication, etc. If you take cross multiplication, etc., you will get one term. You will get one term. But be clear in this. Generally very rare question, but concept point of view, I need to give that point. That's why I'm taking this entire mathematics. Right? Okay, now, sir, R1, R4, right? R1, R4. Here, R2, R3. Here, R2, R3. 1 second. I will write for easy understanding purpose. I am extending one step. Now, R2, R3 plus R3 by j omega C2. Now, I'm bringing this to other side. So R1, R4 equal to this one. What is that? Here, 4 terms will be there. R2, R3 into this. R2, R3 plus j omega R1, C1, R2, R3 multiplied with this plus R3 into this one. R3 into this one. If you're taking this entire thing, the lengthy model of the equation is coming. Yes or no? After that, we need to separate real and imaginary. You'll get the perfect equation. But in this, real part is somewhat lengthy notation. But what we require ultimately frequency only. But real part related also, sometimes question is there. That should be clear. What is that again? It is going this side. What is that? R3 by j omega C2 into this plus R3 j omega R1 C1 by j omega C2. Lengthy equation is there. Okay, sir, concentrate. J omega cancel. Sir, real term, and here also real term is there. Real term is there. So I'm equating that. Real term, what is that? Sir, R1, R4 is equal to R2, R3 plus R1, C1 by C2. R1, C1 by C2. Clear? Clear, guys? Kindly check it. See, I'm coming again. R1, R4 separated. This term is separated. It is going that side. R2 plus 1 by j omega C2 and R3. Okay, right. R2, R3 and here R3 by this. Now multiply R2 R3 into 1, this one, R2 R3 into this one, again R3 by j omega C2 into 1, R3 by j omega C2 into 1. After that R3 by j omega C2 into this one, j omega cancel. Here R3 R1 C1 C2. Here R3 R1 C1 C2 is there. Clear? Now I'm dividing with R3 R1 on both sides. You are going to get one equation. R3 R1 means you will be getting R4 by R3. R3 R1 means you will be getting R2 by R1 plus C1 by C2. Sometimes what they say, in Wien's bridge, find out the corresponding so and so value. Corresponding so and so means out of these 6 values, 5 values will be given. You need to remember this formula. But our topic is measurement of frequency only. But sometimes in the corresponding Wien's bridge, in the gate model or AC model, in the Wien's bridge so and so values are there. Find out the R3 under the balancing condition, means all values will be given. Find out R3. But as he is asking us to calculate R3, R3 is unknown. No, frequency is unknown. But in the examination, anything may be asked. Okay. Next, imaginary. J omega R1 C1 R2 R3. J omega R1 C1 R2 R3. J omega R1 C1 R2 R3. Here R3 by j omega C2 plus, what is it? R3 by j omega C2 is equal to 0, because other side nothing is there. Right? Now at least simplify this and tell me omega value. Tell me omega. Only simple point I'm giving. Come on. Very good, very good. You will be getting 1 by root R1, R2, C1, C2. Very nice. So what is omega? 2 pi f. So f is equal to 1 by 2 pi root R1, R2, C1, C2. This is what the formula. Suppose if I write, sir, if R1 is equal to R2, C1 is equal to C2, then f is equal to 1 by 2 pi RC. If this condition is, otherwise this is the ultimate formula. This is the total discussion regarding entire bridges. What is it? Resistance measurement, self-inductance measurement, and then capacitance measurement in detail, complete one by one step we have taken. Okay, no problem, no problem. Clear, guys? So this is the complete concept. Actually, mathematical discussion. I'm repeatedly saying completely mathematical discussion only. That's why you need to practice more and more. Clear? Right. Now let us have some questions on this. By looking at the bridge, kindly you should answer that which bridge it is. Which bridge it is. Which bridge it is? Yes, Maxwell's inductance capacitance bridge. Correct. Right. Now, here, just for clarity purpose, I'm giving, sir, this is R1, L1 in our discussion. This is R3, R2, R4, C4. What is asking these two? So direct answer. Sir, what is Rex? Rex means our R1. What is R1? R2, R3 by R4. Direct answer. Lx is equal to, what is it? L1. What is that? R2, R3, C4. R2, R3, C4. That's it. Give the answers. Right. You'll be getting 375 ohm and you'll be getting 75 millihen. That's why I told you. Practice the corresponding bridge and corresponding mathematics also. Everything must be practiced. But after giving this formula, it is very easy. But you need to recollect this formula compulsory. Right. Let me take one more question. Come on. I'm taking this as some Z1. This is Z4. This is Z3. This is Z2, for example. What is that? In the AC bit shown in figure, the detector D reads 0, means balancing condition. Z is made of. This Z is made of. So Z1 is made of. Same logic here, but it is completely mathematics. What is that, sir? Here, Z1, Z4 equal to Z2, Z3. Z2, Z3. But be clear, be clear. Kindly concentrate. Don't substitute the values directly and don't waste the time. Don't waste the time. What you do, first of all, what is Z1? Z1 unknown. What is Z4? So Z4 is, what is that? R4 by 1 plus j omega R4 C4. By writing in this, don't waste the time. Kindly calculate Z4 separately. It's better. Then if you substitute in this equation, directly will be there. Z4 separately. What is that? R4 by 1 plus j omega R4 C4. Sir, what is R4? 10 kilo ohm by 1 plus j. 1 plus j. And here, omega, what is omega? 314. R4, what is it? 10 into 10 cube into, what is it here? 100 into 10 power minus 9. But you need to get this in terms of some value plus or minus j, some value model. That is completely your mathematical skill. One student just type that, so mathematics is easy. Yes, you answer this kindly. Come on. Come on. Different answers. People are giving different answers. Few people are giving 1 plus j, and people are giving minus j term also they are giving, which is correct. Come on. Yes, Gopiraju, yes. I will give the shortcut later, but let the students practice the mathematics. Correct, correct. Gopiraju, correct. But I'll give that shortcut after the procedure. Let the students practice. Okay, right. You get something. After that, simply Z1, Z4, Z2, Z3. Z1, Z4, Z2, Z3. Sir, after getting this, convert this into polar. Convert this into polar form. And Z1 unknown, magnitude and angle is equal to Z2. What is Z2? Only resistor, only this one. 1K and 500K. So 500,000 into 500. Direct answer. Z1 you will get in terms of polar form, and tell me the answer finally. Complete mathematics only. Measurement topic itself is not there. Right. 50 plus J, 15.7. 50 plus J you are getting. Very good. 15.7. Sir, what is this format? R plus J XL. So therefore, XL is equal to 15.7 is equal to omega L. Therefore, L is equal to 15.7 by 314. What will be there? Yeah, Bharat, I'm coming to that shortcut later. 1 second. Yes, you'll be getting 50 millihenry. Therefore, resistance is 50 ohm, inductance is 50 millihenry. So automatically both are in series only. R plus JXL form series. So therefore, what is the answer here? 50 millihenry and 50 ohm series. This is what the procedure here. For practice purpose of mathematics, I gave you this entire thing. Kindly check it, Shreya Shashi. Kindly check it. It is 15.7 only. Check it once. Right, 1 second, yeah. But without doing this entire thing, directly we can answer. Everyone, those who are on the line, kindly concentrate. Don't type anything, don't write also. Kindly concentrate. What is that? Simply you need to understand this is similar to which bit? Sir, resistors. One is RC combination, which is that this is possible with respect to which one here? MICB, Maxwell's inductance. Sir, resistance, R and C parallel combination. This will be RL series combination only. So RL series, only one option. So directly answer. RL series, only one. RL parallel, RL series, RC series, RC parallel. Directly second option without wasting a without wasting this much of time. We can answer it. Few people ask that, sir, in the examination with the calculator, is it possible? Means here this is the shortcut. But as it is a practice session, I made you to practice. That's it. Clear? Got it, guys? Shortcut is clear, everyone? Direct it is MICB. So direct answer. Right? Very simple, yeah? So that's what. This much of lengthy numerical based questions will not be there with the virtual calculator. That's why I'm giving the shortcut. That's why if the question is given like this, don't waste the time. But practice purpose, I made you to do all this. But simple shortcut is, sir, resistance and resistance. Two resistors opposite. One is RC parallel. You go through all the inductive bridges. Only MICB is possible. So automatically Maxwell's inductance capacitance bridge. That's why RL combination. That's what the point. Right? RL combination is there. See, RL series combination over. One is RL parallel, RC series, RC. Three options anyway. Wrong only. That's why directly we can get the value. Dinesh, already we determined this resistance. R is directly there. Clear, guys? Right. Take one more question. I will do this, kindly answer. I will do this, kindly answer. Right. Concentrate here. A sharing bridge is used for, see, electrical people, I'm saying once again, I got the schedule for electrical people. What is it? I'll tell you. What is it? I'll tell you. Right. Concentrate. Sir, sharing bridge means immediately you need to draw the bridge compulsory. What is that? R1, C1. Right? After that, R3, C2, R and C. Right? This is E comma F something. Okay, right. Sir, this is R3. This is C2. This is R4. This is C4. Don't forget, these two are the variable elements. Already we studied this. Okay, don't try, I'll do it. See, a sharing bridge is used for measuring the power loss in dielectrics, means dielectric loss, delta, angle, or dissipation factor for that. Okay, the specimens are in the form of, sir, which is specimen for us? Specimen means generally unknown branch, but he has given specimen details are given. Specimen details are given like this. So therefore, sir, this is a specimen. How these details are given, you know, concentrate here. 0.3 centimeter thickness means dielectric thickness means distance between the plates. Have a dielectric constant of epsilon r is 2.3. The area of each electrode is 314 centimeters square, and the last angle is 9 degrees. The last angle is 9, means which one? Delta is given as 9 and the frequency is 50. That's why be careful. R1, C1 directly values are not given. R1, C1 physical dimension. Simply R, suppose R equal to rho L by A will be there. No. Instead of giving ohms, rho value, L value, A value, in the same way, capacitance also. C is equal to epsilon A by D. These dimensions are given indirectly. Indirectly, those dimensions are given. Okay, right. Sir, what is the formula? Concentrate here. After that, the fixed resistor, this is very important here. In the entire sharing bridge, which is a fixed resistor means people are saying that, sir, this is fixed, but that is a specimen. Other than that, this is a variable, this is only fixed. Therefore, how much value? 1000 ohm is given. And fixed capacitance of the circuit is 50 picofarad. But people, without reading that, people are thinking that, sir, R1 is unknown, C1 is unknown. No, yeah, concentrate. Determine the values of variable resistor and capacitor required. Means R4 and C4 he is asking. R4, C4 he is asking. Got it? This is what the only question I explained so far. Specimen means generally in our sharing bits. This is the unknown branch generally, but he has given that value indirectly. Other values are given. These two values he is asking. It is previous gate model, so kindly concentrate. Right? Okay. Now the question is, sir, first of all, so what is the C1 formula? Epsilon naught, epsilon R, A by D. Everyone concentrate, concentrate. You need to give the value at any cost, concentrate. Sir, epsilon naught, 8.854 into 10 power minus 12. There. Epsilon R given 2.3. And area given. Distance between the plates. Thickness of the dielectric means distance between the plates. Everything is given. You need to give this value in terms of farad. 1 second. After that, after getting C1, so how do you get R1? That is playing the major role. Sir, dissipation factor D is equal to tan delta is equal to omega R1 C1. D equal to tan delta equal to omega R1 C1. Sir, delta is given. C1 is there. Now, we need to find out R1 value. Clear? These two steps must be done because in order to get these two values, R1, C1, anyway you require. That's why based on the fundamental concept, C1 epsilon A by D, R1 from the dissipation factor. Delta is given 9 degree. Substitute and get it. But be clear. After this, we are going to find out R1 and C4. How? I'll tell you. First, give me the C1 value, everyone. Give me the C1 value. Preeti, kindly check your value because small decimal point problem is there. Figure is same, but decimal problem. Yeah, Vinita, correct. Yeah, cartoon. Stay with the yes. Sir, answer here is 213 or 214. No problem. Picofarad. This is the correct answer. Few people give the correct answer. Kira, are you getting 4.26 kilo? No. I'm asking this resistance. R1, I'm asking. R1. Are you getting 4.26? Kindly check it once. Definitely area of cross section or anything should be taken in compulsory meters only, at any cost, always in meters. Yes, Krishna Sai, meters only. Likita, 2.3 microfarad. Check it. Right, after this. If you substitute this, you will be getting answer as 2.36 mega ohm. 2.36 mega ohm. Okay, after that, Let us go back to our sharing bridge. What is the result in the sharing bridge? Concentrate here. R1 equal to C4 C2 by R3. C4 C2 by R3. Everything is known. Therefore, C4, this is what he is asking. This is not he is asking this. He is not asking this. Simply here we need to find this, calculate this. And C1 equal to R4 by R3 C2. R4 by R3 C2. Simplify. Find out R4 value. Oh, okay. We substitute all values. R1 is there. C2, R3 already given in the question. Simply C4. Very nice. C4 is 0.118 microfarad, 4.26 kilo ohms. Correct. Correct. Chaitanya Kumar and Hema, correct. Sri Vidya, correct. But 0.11 here you are given, micro or something not given. Yes. Yeah. 180 nano, etc. No problem. Correct. All are correct. This is the total discussion regarding bridges. Right? Now, I'm giving one question as a homework question. Try this. If not, I'll solve in the next class anyway. Don't worry. Take this as a homework. Right? So this is the, actually speaking, this is the total syllabus according to the given thing, but few miscellaneous topics are there. Sometimes, actually that is not mentioned, but sometimes useful. Measurement of power factor and measurement of frequency, so and so meter, etc. I'll be taking that in the next class, no need to worry. But before that, simple idea I'm giving. Sir, measurement of mutual inductance. Only miscellaneous topic here. This is actually not there in the syllabus, but if anyone is writing any state level examination in your own state, their gunshot questions will be there. For that purpose, safety point of view only I'm giving. Measurement of mutual inductance. But it is not there in the syllabus. No need to worry. ESC objective maybe, chance may be there, and other state level examinations, concept they don't require, which bridge is used for mutual inductance, like that they are asking. Right? So this is the thing, right? So bridge has to be simplified, and any question mean that will be possible generally with respect to which one? Yeah, resistive bridges. And I gave one more question also here for lengthy procedure. In this way, I gave you. But as a shortcut is there, I gave shortcut. But other than thing, procedure only there. Okay, right. Now, in this direct gunshot points I'm giving a first one. What is that? Heavisides mutual inductance bridge. Heavisides mutual inductance bridge. Right? Simply in the other examinations, especially mentioning that in the other state level examinations, which are the following bridges used for mutual inductance over. For them, idea purpose I'm giving, but in the gate point of there is no question on that. There is no topic actually. But idea purpose I'm giving. Sir, in this what I'm giving, sir, so far we have taken, suppose MICB I'm taking, for example, some bridge I'm taking, Owens bridge, for example. The question is, sir, unknown inductance is determined in terms of known capacitance or known inductance. This is the question, for example. I'm coming again. In the Ohm's bridge, unknown inductance is determined in terms of known capacitance or known inductance means known capacitance only. That is what Ohm's bridge. Okay. In the same way, if I take other bridge, Hayes bridge, then the Hayes bridge, do not ask objective question here. Maxwell's inductance capacitance bridge, unknown inductance is determined in terms of known capacitance. Yes or no? So in this way, I am giving the conclusion. If I come to MI bridge, Maxwell's inductance bridge, unknown inductance is determined in terms of known inductance. Yes or no? From this result only, we can make the statement. That's why I'm giving the direct note as the safe side miscellaneous point. What is it? With this bridge here, unknown mutual inductance is determined in terms of known self-inductance. Means M is equal to some L into something, etc. Means unknown mutual inductance is determined in terms of known self-inductance. M in terms of L. In the same way, exactly reverse. What is that? Modified form of Heaviside mutual inductance bridge. What he has done here? Simply he modified the bridge. Simply small modification he has done. He has given exactly reverse concept. What is that means? Unknown self-inductance is determined in terms of known mutual inductance. Exactly reverse. But don't get confused. Sir, heading is mutual. No, yes. Our topic is this only. But one more person modified that bridge, and he has given the reverse concept. Mutual inductance in terms of self-inductance in terms of mutual. Exactly reverse concept he has given. That's it. Right? You need to follow these two things. Mutual inductance in terms of self, Heaviside. Self in terms of mutual, that is modified Heaviside's bridge. Okay. Otherwise, actually, this entire modified form given by whom? Campbell's. That's why we can write Campbell's modified form of Heaviside's bridge. Campbell's, I'm writing the name clearly. Instead of writing separately, I'm writing here only. Campbell's modified form of Heaviside's bridge. Campbell. Who modified? Campbell, other person. Campbell's modified Heaviside's what is that? Mutual inductance bridge. One thing. Next one is third one. Carey-Foster's. Head-Wheeler's bridge. Names are different, right? Carey-Foster's Head-Wheeler's bridge. So what is Carey-Foster's? Very simple here. Here, unknown capacitance are here. Unknown capacitance is determined in terms of known mutual inductance. Unknown capacitance is determined in terms of known mutual. Means earlier two bridges are relation between self and mutual inductances. But here these people propose capacitance and mutual inductance relation. Exactly, it is reverse. What is that? Unknown mutual inductance is determined in terms of which one here? Known capacitance. Exactly reverse. Kindly take this as just simply safe side point only. Otherwise, I can close it, but simply idea purpose I gave you. Clear? Right. All these are try to understand my English. All these are just miscellaneous topic. This is not there in the syllabus. But state level examinations, without state level examination, concept is not required. Mostly gunshot questions will be there. This is for this, that is for that. Why? We don't know. In that way, preparation. That's why for them, I'm giving just idea purpose. In this class only means with my class notes, you can write any of the examination. In that way, I'm giving miscellaneous topics also. Right now, final one more miscellaneous point is simple logic here. Which of the following method is used to eliminate the stray capacitance effect in the AC bridges? Means one person gave one concept like Wagner's grounding. Wagner's grounding means he has given one concept of grounding concept. What is that? In the AC bridges, internally capacitance is there, except Maxwell's inductance bridge. Every AC bridge is with at least one capacitance. Therefore, external side stray capacitance effect will be there. That's why Wagner's proposed one grounding concept, so that whatever the stray capacity is acting, that will be automatically grounded, so it will not disturb the corresponding, what is that, bridge. That's why this is grounding concept used. But objective paper point of view, that too, in the other examinations only, dash is used to eliminate the stray capacity effect, like this one only. So simply to eliminate stray capacity, to eliminate effect of stray capacitance in the AC bridges. These two are just safe side. For other examination purposes only I'm using. So this is a total discussion regarding entire bridges chapter from starting day to last one. Starting day to last. Clear? Right. Now you can ask any doubt. Let us have the doubt session. Any doubts you can ask now. Today is completely mathematical approach only. No concept actually mostly. Right? Ranges are not there for dissipation factor. No need to worry. Ranges are not there for dissipation factor. No need to worry. Sir, which areas we should more concentrate in revision? Kindly in the measure in the gate point of view, generally this topic more questions will be there, etc. No, because every year the IITs will be changing. Last year IIT Bombay, this year IIT some other, next year IITs like that will be there. So we cannot expect that. That's why try to follow everything in the gate to get the best rank. Now I'm giving the schedule of everyone now. Schedule of everyone. Kindly concentrate here. Electrical people schedule and IN people schedule I'm giving. Concentrate here. Right. See, IN people 17th, right? 7 p.m. to 9 p.m. electronic measurements. Okay. And electrical people. One second. But for both the batches, electrical and instrument. Hello, Venkat. Right. See, 17, because 16 tomorrow holiday for everyone. 17, 5 p.m. to 9 p.m. power systems. But my topic is only one small topic, half an hour topic. After that, revision point of view I'm taking on Sunday. What is a Sunday date? 20, right? 20th, 9 a.m. 2 I'm not giving, 9 a.m. it will be completed. That is electrical measurements pending one. Kindly don't miss this last class for related to measurements, electrical measurements. Kindly don't miss this. Don't miss this because I'm going to take 1, 1, 1, 2, 2 questions from all the topics. This is what your schedule. Right. So one more. Yeah, this is major problem, sir. Electronic measurements is there. Electronic measurements is there for electrical people. That will be later. That will be later. Electrical people, I will take electronic measurements separately later. Right. I'm going to make electrical people after a few days for electronic measurements subject. Yeah, very good. On 17th, triple E people don't have class. You guys see, concentrate. 17th, electrical people, double E, electrical only. 5 p.m. to 9 p.m. power systems. 17th means day after tomorrow. Is everything clear? Vashishta, very good question. First time I'm getting this question. Yes, very good. Yeah, many people, except through 2, 3 people, that is common everywhere. That will be there. You answered in a very good manner. Yes, but only one thing I would like to give one suggestion. I would like to give one suggestion. Kindly, right? Take it as a positive way, right? Kindly, while the faculty is explaining, kindly don't type the messages. Don't type the messages. Definitely you will. That too, my way of teaching is the moment message is coming, I will see that message. I will clarify that immediately. Generally, that is what. But each and every faculty has their different idea. Few people generally don't see the message, etc. So that's why unnecessary. Don't waste the time in typing those messages. Why the lecture is going on? Once the faculty asks you to, what is any doubt is there, clear or not, at that time only you need to type the message. Transducers, EE, ESC, that is later. That is later. Parts wise we will be taking here. Parts wise we will be taking, no need to worry. Right. Yeah, just I have given pass to my subject. That's it. Electrical measurement almost done. Only small thing is electronic measurements later for both the branches. Electrical and instrumentation people, electrical measurements is there. Electronic measurements is also there. Is also there. Digital meters, all those, and we'll be taking in the electronic measurements. Sir, only you see message. You only see message. Okay, thank you. Yeah, regarding schedule, other than that, etc., we'll be you will be coming to know. Power system will be there, no. Other subject you will come to know. Right. EMMC type meter compensation, that is miscellaneous topic. I'll give you low power factor meter compensation winding geyser. I will give you on a Sunday. All miscellaneous topics will be taken. Very good. Vaishnavi, sir, what is the use of drawing phasor diagrams in finding the measurement of index? Actually, in the normal questions point of view, explain Maxwell's inductance bridge in detail means construction, circuit diagram, mathematics, quality factor, phasor diagram. Then you will get the complete mark. But objective paper point of view, phasor diagram drawing will not be there. But once we draw the phasor diagram, we will get the concept of RL, RC, RLC, series, parallel. For that purpose, I have taken. Otherwise, my topic will be very simple. Phasor diagram is not required, I can say. But a concept point of view, I need to explain. Right, sir, you told that you will discuss about PSUs and all. Kindly do that. Definitely, on one day I'll take. No need to worry. Right. Preeti Kezia, thank you so much. Thank you so much. You're electrical, right? You're electrical, right? See, generally in the offline classes, I will teach measurements as well as network theory also in few centers. Otherwise, out of few center Bhopal and different places. But this is online session, no, yeah. So that's why I'm not taking network theory. I'm taking only measurements to you people. Right. Hardware instrument, that is AC measurement, RMS measurement, all those will be covered in the last class. Miscellaneous topics. Don't worry. Thank you so much. First, you need to say, right. Thank you so much. Vashishta, you're from which college? Because every time many people answered properly. Yes, I could remember few names. Yeah, MG. Okay, right. Very good. Did you take classes in Chennai Center? Yes, yes, I'll take Chennai Center measurements. But not now. Then nowadays only online, single class only. Right? Dwarakesh, yes, I regularly come to Chennai. Very good, very good. Thank you so much. Right. See, people are asking, see, I will teach generally, people are asking, right? I will teach all over India in 14, 15 centers in all AS Academy branches. I will teach Delhi, Bhopal, Patna, Lucknow, right? Kolkata and Chennai, Pune, Bangalore, everywhere I'll teach the measurements. But in few centers, network also. Up to before COVID, I used to take, but online, no, I'm not taking because other person is there, he is taking. Right. Thank you so much. Tomorrow, holiday for everyone because I have not given the break on Saturday. No, yes, tomorrow I have some work. That's why. Dasharath, can you message me personally? I'll tell you what is my native place and all. See, only one thing here. People are asking, sir, how is Chennai students? How about Maharashtrian students? I love everyone. I love everyone. Only the thing is, I will shout at the people when the people behave without a common sense. That is what my headache. If you don't have the subject, I am here to give the subject. But common sense, I cannot give. That's why sometimes only 2, 3 people I shouted at them, but don't mind, that is for your sake only. But everywhere, I love the people definitely. People used to come to me still, so many 6 years, 7 years back students also still in touch with me. Regular, they will do the message, etc. If I go to those places for teaching in the leisure time, I'll meet them. Very good. Even if you shout, we love you, sir. Thank you so much. Yeah, career opportunities, we'll see that later. No problem. Right. Prakash, thank you so much. Due to my health issues, who is this? I'm unable to do your class regularly. Can I ask doubts in this? Definitely. Yes, Saujanya. Yeah, I have not seen so many days. Right? No problem. Kindly, yeah, kindly. No need to worry here. I give my number. Feel free at any time. I will clarify your doubts, but don't expect in the next minute only. If you send any doubt, don't expect. That's why you can call me, you can message me, feel free. If I don't attempt your call, think that I'm in the class, so that I will be answering that later, definitely. No need to worry at all at any time. But be clear, guys, this is a pandemic situation. Don't come outside. Kindly take some precautions, right? Kindly be at home only. Take the vaccine. 18 plus already came into picture. No, take the vaccine. Be safe first. Health is first. After that, studies after that only. Health is first. Yeah, Vaishnavi, you're right. My turn is over. Now your turn is there. Preparation. Yeah, my job profession is only teaching. That time I'm a permanent faculty for ACE Academy. Permanent faculty in ACE Academy. General, I will take measurements, feedback network theory. For IES people, ECE, BW means missions related subject. I will take for ECE people. Sir, Shreya Shashi. Sir, is there any chances for Sunday afternoon class to be conducted morning? Sunday morning only there, yeah? 9 a.m. class is there. 9 a.m. class is there. Electrical measurements. Definitely, Vashishta, definitely at any time. But if I don't attempt any person call, kindly message that, sir, this is a previous batch student, like that. Just remind me, I'll call you back. Just drop a message. Pavan Kumar, you will come to know. You will come to know that later. You will come to know that. Ah, that's what. Okay. You will come to know that later here. Right. People are asking. I think new people, I think, yeah, this is my WhatsApp number. While you're sending the question, no need to give any detail of your personal detail. No, but just only it's a recent batch, 2022 batch. Like that you give, I can recollect. Practically means, come on here, simply in the laboratory point of view, right? In the bridges point of view, unknown branch is there. No, this is the coil. You need to keep that coil in the corresponding bridge terminal. Vary that until the bridge. Means practical approach only, measurement. Actually, mails, I will rarely check the mails here. Kindly, mostly send to my number only. Right. See, Kiran Kumar, you're from Vizag. Okay, right. Very nice. Whenever I come to Vizag, yes, definitely. Yeah, Telugu places Vizag, Tirupati, and Vijayawada also I'll take. All the places, measurements, I will. Here, people are asking my qualification. I'm pursuing my PhD. Okay, oh, you are not on WhatsApp. You are not on WhatsApp. Okay. Then you can send through mail ID, no problem. I will see 2 days once it's I will see, no problem. Definitely, Vinitha, definitely you can call, no problem. Definitely, anytime you can call. If I'm in the class, I don't attempt. Otherwise, I will attempt the call, no problem. And few people also know that I call them and I clarify doubts also after sending. No problem. If you send me the question, if I need to explain orally, I'll call you back and I'll explain. No need to worry. That's what. Vaishnu, if anyone is not on WhatsApp, very good actually, very good. You can send through the mail. Yeah, the ohm meter, resistance meter. Yeah, why? What is the doubt? Shravani, what is your doubt in the ohm meter?
Sir,
Yeah.
సార్ మెజర్మెంట్ ఆఫ్ ఫ్రీక్వెన్సీలో మీరు కెపాసిటర్ కి రెసిస్టెన్స్ కి కెపాసిటర్ అని ఫ్రీక్వెన్సీ చేంజ్ చేసినప్పుడు అలానే ఒకసారి ఏమో చెప్పారు కదా సార్, నాకు అది అర్థం కాలేదు, ఒకసారి చెప్తారా
ఏం
సార్?
చెప్పానమ్మా ఇక్కడేనా ఇదేనా
సార్ ఇదే సార్. కెపాసిటర్ కి రెసిస్టెన్స్ అని రాశారు ఫస్ట్, రెసిస్టెన్స్ కి కెపాసిటర్ అని రాసి ఫ్రీక్వెన్సీ చేంజింగ్ అనేది చెప్పారు కదా
లేదు
సార్.
లేదు 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 యాక్చువల్గా పొరపాటున R1 C1 కదమ్మా, పొరపాటు ఇలా రాస్తాను నేను, అయితే మళ్ళీ చూసి తీస్తాను అంతే. ఆ తర్వాత ఏంటంటే నేను ఏమడిగానంటే ఈ 4 వాటిల్లో ఏది అన్నోన్ అడిగాను, ఎందుకంటే ఇది రాయకుండా అడిగాను అనమాట. ఈ రెండు రాయకుండా అడిగేసరికి ఏంటంటే ఫస్ట్ బ్రాంచ్ కదా అన్నిటికీ అన్నోన్ అని, ఫస్ట్ బ్రాంచ్ అన్నిటికీ అన్నోన్ అని చెప్పేస్తున్నారు. కానీ ఏది అన్నోన్? ఫ్రీక్వెన్సీ అన్నోన్. ఆ తర్వాత చెప్తూ అనుకోకుండా పొరపాటు ఇలా రాశాను, మళ్ళీ చూసావు రివర్స్ రాశాను కానీ మళ్ళీ చేంజ్ చేశాను అంతే, తప్పితే ఏది మిస్ అవ్వలేదు ఇక్కడ. పొరపాటుని రివర్స్ రాశాను అంతే.
ఓకే సార్.
అంటే
అది
రివర్స్
R1 దానికి రివర్స్ రాసి ఏమో చెప్పారు సార్, నాకు అది అర్థం కాలేదు అందుకనేసి.
యాక్చువల్‌గా రివర్స్ రాసి అనుకోకుండా రివర్స్ రాసి ఫ్రీక్వెన్సీ అన్నోన్, ఈ బ్రాంచ్ అన్నోన్ కాదని చెప్పి మళ్ళీ అబ్జర్వ్ చేశాను. అరే మళ్ళీ రివర్స్ ఎరేజ్ చేసి రాశాను అంతే.
ఓకే సార్. సార్
మిస్
నిన్న
అవుతుందా?
నిన్న మొన్న క్లాస్ వినలేదు సార్, అంటే కొంచెం
యాహ్!
ప్రాబ్లమ్ ఉంది, వినలేదు సార్. నేను మళ్ళీ తర్వాత వింటే ఏమైనా డౌట్స్ ఉంటే అడగొచ్చా సార్?
యాహ్! డెఫినెట్‌లీ. నేను చూసాను మీ నేమ్ కనిపించలేదు లిస్ట్‌లో, అందుకే అడుగుతున్నాను వినలేదని.
ఓకే సార్.
రైట్. ఓకే అమ్మా పర్లేదు.
ఓకే సార్.
అడగొచ్చు ప్రాబ్లమ్ లేదు. Who is this? Shravani, you can unmute from your side and you can speak with me if you have that doubt regarding the doubt. Vinita, you raise the hand. No doubt. Imtiaz, you raise your hand. Unmute.
Good evening, sir.
Yeah, good evening. Tell me.
Sir, just one small dot in substitution method.
Yeah.
Sir, మేము అన్నోన్ రెసిస్టెంట్ అంటే ఫస్ట్ పొజిషన్ లో కనెక్ట్ చేస్తాం కదా సార్ ఆర్ కి.
అవును.
అప్పుడు అంటే రియోస్టాట్ కి అవసరం లేదు కదా సార్, డైరెక్ట్ అన్నోన్ రెసిస్టెంట్ డైరెక్ట్ అమ్మీటర్ కనెక్ట్ చేస్తే అప్పుడు అమ్మీటర్ లో రీడింగ్ చూపిస్తాయి కదా సార్.
అయితే వెరీ గుడ్ క్వశ్చన్. అయితే రియోస్టాట్ అవసరం ఏంటి అంటే, సపోజ్ మీరు అన్నోన్ రెసిస్టెన్స్ కనెక్ట్ చేశారు. అన్నోన్ రెసిస్టెన్స్ కనెక్ట్ చేయగానే అమ్మీటర్ లో 0 టు ఫుల్ స్కేల్ ఉందనుకోండి. సపోజ్ అమ్మీటర్ ఈ వాల్యూ చూపించింది అనుకోండి, మీకు ఏమని చెప్పాను, ఇది డీసీ కదా, డీసీ మీటర్ కదా,
అవును
అయితే
సార్.
టువర్డ్స్ 0 ఉంటే ఎర్రర్ ఎక్కువ ఉండే ఛాన్స్ ఉంది కదా.
ఎస్ సార్.
అందుకని రియోస్టాట్ ప్లేస్ చేసేప్పుడు కన్సిడరబుల్ కరెంట్ అన్నాను, అంటే ఈ కరెంట్ లేదా మిడిల్ కంటే ఎక్కువ కరెంట్ తీసుకోవడానికి ట్రై చేసాం, ఎందుకంటే ఎర్రర్ ని మినిమైజ్ చేయడానికి అంతే.
ఓకే, అంటే నేను కొన్ని కన్ఫ్యూజ్ అయినా సార్, అంటే రియోస్టాట్ మళ్ళీ ఎందుకు అవసరం అని. జస్ట్ సార్ అంటే రియోస్టాట్ ఎందుకు అవసరమా, మళ్ళీ రెసిస్టెంట్ ఉంది కదా
ఏం చెప్పారంటే బై వేరింగ్ ద రియోస్టాట్ అబ్జర్వ్ ఏ కన్సిడరబుల్ కరెంట్ ఇన్ ద అమ్మీటర్ సే ఎక్స్ ఆంపియర్స్ అని చెప్పారు. అది ఇప్పుడు క్లియరా?
ఎస్ సార్, అంటే స్టార్టింగ్ లో కొంచెం మిస్ అనుకున్నా.
నో ప్రాబ్లం.
థ్యాంక్ యూ.
Right. Other person, who is this? Vinita and Harshita.
Sir,
From you, yeah.
sir, swamping resistor ఎక్కడ యూస్ చేస్తాం సార్?
స్వాంపింగ్ రెసిస్టర్ అంటే కాన్స్టెంట్ టెంపరేచర్ కోఎఫిషియంట్ కావాలనుకున్నప్పుడు, అందుకని ఆర్ఎస్హెచ్ ఆర్ఎస్సి కూడా స్వాంపింగ్ రెసిస్టర్ అంటాం మనం. అంటే ఎప్పుడైతే కాన్స్టెంట్ టెంపరేచర్ మెజర్ చేయాలనుకుంటున్నామో, లేదంటే ఇండిపెండెంట్ ఆఫ్ టెంపరేచర్ ఆపరేషన్ కావాలనుకుంటున్నాము, అక్కడ మనం స్వాంపింగ్ రెసిస్టర్ యూజ్ చేస్తాం. మీకు షంట్ మల్టిప్లైర్ అయిపోయింది చెప్పాను, ఆర్ఎస్హెచ్ ఆర్ఎస్సి తర్వాత.
ఎస్ సార్.
అంటే సింపుల్, అంటే స్వాంపింగ్ రెసిస్టెన్స్ అంటే ఇట్ ఈస్ ఎ రెసిస్టెన్స్ విచ్ ఈస్ మేడ్ అప్ ఆఫ్ కాన్స్టెంట్ టెంపరేచర్ కోఎఫిషియంట్ ఆఫ్ మెటీరియల్ సచ్ యాజ్ మ్యాంగనీన్ అండ్ కాన్స్టాంట్ అండ్ సో అండ్ సో. ఎక్కడ యూజ్ చేసాము? ఆర్ఎస్హెచ్ ఆర్ఎస్సి. సింపుల్. ఓకేనమ్మా?
ఓకే సార్, థ్యాంక్ యూ సార్.
one more student. Who is this? Yeah.
Sir,
Yeah.
it's a 38 F flow, sir.
38.
F, yes, sir.
Yeah.
సార్ ఇందులో మొత్తం ప్రొసీజర్ అర్థమైంది బట్ ఆ షార్ట్ కట్ ఒకసారి చెప్తారా సార్?
సింపుల్ అమ్మా. ఓకే, ఇదేంటి రెసిస్టెన్స్ కదా, ఇది కూడా రెసిస్టెన్స్ 1 kilo 500 ohms అంటే యాంగిల్ అలాంటివి ఏమీ లేదు కాబట్టి రెసిస్టర్ మీనింగ్. అయితే టూ రెసిస్టర్స్ ఉన్నాయి, అలాగే ఆర్సి ప్యారలల్ బ్రాంచ్ ఉంది. మనకున్న అన్ని బ్రాంచెస్ లో ఒకసారి చూద్దాం. 2 రెసిస్టర్స్, ఒక ఆర్సి ప్యారలల్ బ్రాంచ్ ఎక్కడెక్కడో చూద్దాం ఒకసారి. హియర్ 2 రెసిస్టర్స్, ఆర్సీనే లేదు ఇక్కడ, వదిలేయండి. ఎంఐసిబిలో 2 రెసిస్టర్స్, ఆర్సి ప్యారలల్ ఉందంటే ఆటోమేటిక్ ఇక్కడ ఏముండాలి, ఆర్ఎల్ సిరీస్. ఓకే, ఇంకోటి హియర్స్కి వెళ్దాము, ఆర్సి ప్యారలల్ లేదు. ఓన్స్కి వెళ్దాము, ఆర్సి ప్యారలల్ లేదు. ఆండర్స్కి వెళ్దాము, ఆర్సి ప్యారలల్ లేదు. ఆటోమేటిక్ బ్రాంచ్ ఏంటమ్మా? యా, ఇది షార్ట్ కట్ ఏంటంటే, ఒక్క నిమిషం. యా, దిస్ వన్. యా, చూడండి, ఫస్ట్ ఏంటి, ఆర్ఎల్ ప్యారలల్ అన్నారు, రాంగ్. థర్డ్ ఏంటి, ఆర్సి సిరీస్ అన్నారు, రాంగ్. ఆర్సి ప్యారలల్ ఓన్లీ ఆర్ఎల్ సిరీస్. ఎస్, సెకండ్ ఆప్షన్ కరెక్ట్.
ఓకే, అండర్స్టూడ్.
యా. B. Shirisha, swamping resistor, it is a resistor which is made up of, it is a resistor which is made up of constant temperature quotient of element, that is called a swamping resistor. Okay, next. Mamata, how to decide, that is experimentally given here. You need to follow that as it is. Mamata, how to decide that means experimentally given, we need to follow that as it is. We need to follow that as it is. Okay, guys, almost all raised hands explained, right? All the best, guys. Be in touch with the doubts clarification. All the best. Thank you. Good night.